So today we are going to do step 4 algebra, and you can follow along in my booklet, okay? So in order for you to understand algebra, this is going to be very tough. You need to really understand and remember what we covered in steps 1 and 2. I'm assuming that you have already watched steps 1, 2, and 3, and you really have a good comprehension of steps 1 and 2 specifically, okay? So let's start with the basic concepts of algebra first. Okay, so let's start with what we already know. So far, like in steps 1 and 2, we covered numbers. If you put a number 3, it's it's number 3. You got 3, right? And that's called a constant because we know what that is. A constant means it doesn't change. 3 means 3, right? So in algebra, we will be dealing with something like x, and x is called a variable. Okay, variable means that it takes a different value. I don't know what the value is. It's unknown. I don't know. Variable means that it can take any value. So x, for example, it could be the basket of apples. So I don't know how many apples are there in the basket. So I just call it x. I've got x apples in the basket, okay? X could be 4, it could be 5, it could be 6, it could be any number, right? So x is called a variable, so the letters are variables. And then we can mix and match constant and a variable, so we can have 3x. I can write that. And when I write that, what do I mean? So 3 times the basket of apples, right? So that means that I've got 3 baskets of apples, okay? Then each basket I may have 8 apples, so 3 times 8 will be 24, right? If I know the value of x, then that's how I would do things. But here I don't know. I've got 3 baskets of apples. I don't know how many apples are there in each basket. And this, we said that the constant, and then when I use the constant along with the variable, and it is called the coefficient, okay? And this is still the variable. Okay, so this is the variable. So 3 times x means 3 times the basket of apples or whatever that x is. Then 3 is called the coefficient. That's a constant. Okay, so you need to remember all the terminologies. So and then this 3x, when I combine the constant and the variable, and this is called a term. Okay, term means that it's a collection of numbers and letters, okay? So for example, x, y, z, I can have any number of letters, so that'll be called a term, okay? So then you need to remember certain things. When I write x, so that means that I have 1x, right? So that's what that means. So coefficient of x is actually 1. But we don't usually write 1x, we write x. That means that automatically the coefficient is 1. That's what that means, okay? Also, you need to remember all the exponents we covered before. When I write x, I mean x to the 1. I don't have to write x to the 1, but I really mean x to the 1, okay? So, and then we covered before, so for example, when we covered the exponents, so for example, when you have a 2 divided by 2, we know that any number you divide by the same number, it's always 1. You know that, right? Always. So 3 by 3, that's 1. 3 over 3, that is actually 1, right? So any number divided by the same number, it's always 1. So then in the exponent, the way we wrote that, for example here, so this is 3 to the 1, this is 3 to the 1, right? So in the exponents, the way we did that, so how do you divide the exponents? So this equals 3 to the 1 minus 1. So you subtract the exponents. So 1 minus 1 is 0. So 3 to the 0 is 1. So this we already did that in step 1. Any number raised to the power 0 is always 1, right? Because of this reason. So you are dividing the number by itself. So that means that, that number raised to the power 0, that is 1. Similarly, when you have x divided by x, so you are dividing x by itself, so the answer is 1. You already know that. But I said this is x means that x to the 1. So when I use the exponent, so then what do? So when I divide the two exponents, I am just subtracting the exponents. So x to the 0 is always 1. So any letter raised to the power 0 is always 1. Okay? And then the other thing is, here we call it the term coefficient and then x, right? 3x. So 3x means 3 times x, right? So we don't put a dot, we don't want you to get confused with decimal. So 3 times x, so it's like a 3 times x. So we don't use the cross symbol because you will get confused. So instead of that, we generally use 3 times x. We put the asterisk 3 times x. And some books, they put like a 3 dot x, that is 3 times x. And that we write it as 3x. 3x means that automatically 3 times x. That's what that means, okay? And you can write that as x3. You can write it that way also, right? The same thing. So because if you write like a 3 times 4 is 12, 4 times 3 is also 12. Similarly, 3 times x equal to x times 3. But generally, we don't write like x times 3. We always write the coefficient first and then write the letter, 3 times x, but that's also equal to x times 3, okay? So now these are all the basic, terminology you need to know in algebra. So then once you know this, so then we can do just like the way we did in step 1, we've got all these operations, right? We can do addition, subtraction, multiplication, division, same thing you can do with variables, okay? For example, so let's say that I want x plus 2x. I want to add, 2 variables or 2 terms, okay? So what do I do? So then, so the way you do that, so what does this really mean? So x means, let's say it's a basket of apples. I didn't put a 1 here, but I told you, so it's 1x. That's what I mean, right? I've got 1 basket of apples. And then here I've got 2 baskets of apples. So how many baskets of apples I have? 1 plus 2, that's 3. So you add the coefficients. 1 plus 2 is 3, 3x. Okay? So addition means that it's very similar to what we did before. You just add the 2 numbers, which are the coefficients. Okay? So let's say we've got 3y plus 5y. 3 plus 5 is 8, 8y. So you just add the coefficients. Okay? And then you can have x plus 3x plus 7 plus 8. So when that happens, then you want to make sure that only the like terms you will be adding. So that means that apples I'm adding to apples, oranges I'm adding separately, right? So x plus 3x, I will do that, that's 4x. And then I will add this 7 plus 8, and that is 15. So 4x plus 15. So that's how I add. Okay, and then subtraction is very similar. So let's say that I have 4x minus 3x. So that means that I've got 4 baskets of apples minus 3 baskets of apples. So that means I've got 1 basket of apple left, right? So 4 minus 3 is 1x. And generally we don't write 1, right? So you will write it as x. So all you are doing is you are just taking the 2 coefficients. 4 minus 3, that's 1. Right, that's 1. That's what you are doing. And similarly, if I have like a 8x minus 7x, so let's say 8x minus 1x. So let 8x minus x. So here you need to remember, even though I didn't put a number here, so if I didn't put anything, that means that 1, right? So 8 minus 1, so that is 7x. Okay, so this is, you take the coefficient, it's 1 there. So 8 minus 1, that's 7. Okay? So addition, subtraction, very simple. You just, like terms, you will be adding or subtracting the coefficients. Very simple. Okay? So now, let's talk about how do we do the multiplication. So the multiplication, so let's say that x times y, and generally we write that as xy. So xy, with no symbol in between, that means that you are multiplying x and y, okay? So now let's say that I've got 2y times 4z, So then the way you do that, just similar to what we did the coefficients, you multiply the two coefficients. 2 times 4 is 8, 8. Then y, z, so y and z. So you just write y times z is yz, okay? And then let's say we've got 5x and then times x. So 5 times 1, so the coefficient is 1 here, right? So 5 times 1 is 5. Then x times x is x squared, right? So got the exponent 1, 1, and then when you multiply the exponents, you x times x, that means that you remember we added the two exponents. 1 plus 1 is 2. So 5x squared, okay? So then if we have like a 5x and then times x, and then times y. So what this means is that 5 coefficient is just 5. And then here, x times x, so it's x to the 1, x to the 1, x to the 1. You add the exponents, x cubed, and then times y, okay? So you see that, I don't put any symbol in between. 5x cubed y means 5 times x cubed times y. That's what that means, okay? And then the division is very, very similar. So you just deal with the coefficients. So let's say, for example, I have 4x divided by 2x, okay? So let's say that. And you will divide the coefficients. So 2 goes into 4 2 times, and then x and x gets canceled, same. So the answer is 2, okay? So if we have like a 9xy, and then you divide that by 3xz, so then the coefficients, 9 divided by 3, you divide that, that is 3. Then x and x get canceled, and we've got a y on the top, z on the bottom. That's the answer, okay? Then let's say that I have 6x cubed divided by 2x, okay? So this goes 3 times, right? So I have 3, and then x cubed over x. X means that you need to remember x to the 1. Then when I divide the exponents, then I subtract 3 minus 1, right? So x raised to the power 3 minus 1, which is 2, 3x squared, okay? So you need to be very, very comfortable with what we have covered so far. And if you don't understand any of these concepts, you need to pause here, watch it over and over again, read your book, make sure that you understand these basic concepts, because I'm going to build upon this, okay? So then let's talk about expressions. So when we say monomial, what do we mean by expression? Like a term, like 5 times a, that's an expression, okay? And monomial means that, mono means that one, so monomial means that it's one term. So there is another name, I can call it one term, or I can call it monomial. It means the same thing. 5a is a term, and it's also monomial. 25x is a monomial, it's a term, it's a monomial because I've got one term. 6xyz, that's monomial because it's one term. So binomial means that two terms, okay? So binomial, two terms, what do I mean by that? So if I have like an x plus 5, so I have a plus sign in between, right? So either plus or minus. So I've got two different terms, and then I'm adding or subtracting, then that is binomial. Or x minus 5 is also binomial. Two terms there, right? Or I can have x squared plus 8, or x squared plus y squared, right? Or s plus t. Anytime I have two terms, I can have a minus or plus in between, and that's called binomial, okay? So now, monomial, binomial, trinomial, if you just keep going, it gets more complicated. So mathematicians came up with a different terminology called polynomial. So poly means multiple. So polynomial means that anything greater than one term, you can call it polynomial. So for example, binomial, you can call it polynomial with the two terms, okay? So polynomial here could be any number of more than one term, right? So you can have like a 3 x to the 4 plus 4x squared plus 7x plus 5. And that's called a polynomial because it has got 4 terms. Anything more than one term, 2 or more terms is called polynomial. So we've got 4 terms here, so it's a polynomial. And then I have like powers, the exponents. So the largest power here is 4. So this is a polynomial, and we call it the degree is 4. Okay, so whichever term has got the largest exponent, right? Here it's 4. That's called the degree. And you can have like a 5x squared plus 7x plus 8. And this is a polynomial because there are 3 terms, degree is 2. And then you can have any number of letters. You can have like 5x squared plus 7y squared plus x plus y plus 9. And that's also polynomial because there are 5 terms. And I have x and y. There are 2 different variables, okay? So then rational expression means that if you take a ratio of 2 polynomials, it's called rational expression. For example, if you have this example here, I have x squared plus 3. It's a polynomial with the 2 terms on the top. On the bottom, I have a polynomial with the 2 terms. So it's a ratio of 2 polynomials because ratio means what? I have 1 polynomial on the top, 1 on the bottom, and that's called rational expression, okay? So then, this is what we call expressions, so polynomial and rational expressions. And then how do you evaluate the expression? So what do I mean by evaluate? So for example, so I have x plus 5, and so I don't know what x is, but if I know what x is, then what is its value? So if x equals 3, then what is the value? And this is very, very easy. Evaluation expression is just like a plug and play. You just plug in the number. You just plug the number in. That's all you need to do. So if x equal to 3, I just plug in x equal to 3. So 3 plus 5 is 8. 8 is the answer. Okay? And then it could be a little bit more complicated. For example, 7y squared plus 8y minus 19. And then when x equals 2. Or y equals 2. So let's say that y equals 2. So if I plug in 2 here, I plug in 2 here, I plug in 2 here, right? 7, 2 squared. 2 squared is 4. 4 times 7 is 28. And 2 times 8 is 16 minus 19, okay? And that equals 25, right? So you just plug in the value. That's all you need to do. So that you can do even for rational expression. Let's say that I've got x cubed plus 3 over x plus 4, then let's say that x equals 1. So then you just plug in here 1, plug in here 1. So 1 plus 3, that equals 4. 1 plus 4, that is 5. 4 over 5, 4/5 is the answer. Okay? So the evaluating the expression is very, very simple. You just plug in the number. That's all you need to do. Okay? So then what we are going to do is the simplifying the expressions. So the simplification is we have to pull the like terms together. So let's say that I have 3x squared plus 4x minus 8x squared minus 9x plus 7 minus 10. So when you have a long expression like this, if there are like terms, like an apples and apples, you group them. Oranges, oranges, group them, right? So you need to, the like terms, you need to kind of put them in the same bucket. So for example here, I've got 3x squared minus 8x squared. So how do we add the terms? It's just the coefficients, right? So you need to remember the sign, remember all the rules within step 1. 3 minus 8. So 3 minus 8. So anytime you have a positive, negative, take the difference, right? 5. And the bigger number rules, minus 5, right? 3 minus 8 is minus 5. That's why you need to remember step 1. And then x squared. So the x squared, and then all you have to do is just the two coefficients, you need to add them or subtract them. And then you've got 4x and minus 9x. Again, 4 minus 9, so that's minus 5, and then x. And then 7 and 10, 7 minus 10 is minus 3. So that's the answer. Okay, so when you get the answer, you need to make sure that you don't have any like terms here. So it's like the reducing to the lowest form kind of thing, right? So I've got an x squared, I've got an x, I've got a constant. So in this case, I've got x squared, two x squared terms, x and x, two x terms, and two constants, right? So that means that it's not the lowest form. When you simplify it, you need to put all the like terms together, okay? So let's do another one, bc plus 5bc minus 2bc and plus 9, okay? So here, these are all the like terms, they all have bc, okay? So I need to kind of lump them together. How do I do that? I've got a minus 2, the coefficient, plus 5. So 5 minus 2 is 3. Then you need to remember, I have nothing here, that means I've got a 1, right? 5 minus 2, 3, 3 plus 1 is 4. So 4bc plus 9. So remember this 1 here. 1 plus 5 is 6. 6 minus 2 is 4, right? So you need to remember that. So that's how you do the simplification, just the like terms, okay? So then, similarly, so this is, we did the addition and subtraction. Similarly, the multiplication division, so for example, I have 5 x squared y squared z, then I want to multiply that by 6x cubed y to the 4 z squared, okay, multiplying. So just like the way we multiplied added the coefficients, similarly, you need to multiply the two coefficients. The 5 is a coefficient, 6 is a coefficient, 5 times 6 is 30, okay, I got that. So then the like terms, like x squared times x cubed, so whenever you do the multiply the exponents added up, right? So x raised to the power 2 plus 3, that's 5. And then y squared, y to the 4, 4 plus 2 is 6. And then z, remember, z squared 2, and then this is a 1 there. So 2 plus 1 is 3, okay? So in multiplication, you just multiply the coefficients. Then whenever you have the like term, the same variable, and then you just need to, if they are exponents, so you need to make sure that you are adding up the exponent, okay? So similarly, division, so let's say that I've got 28 x to the 5, y to the 8, and z to the 7, divided by, I have 4 x cubed, y to the 4, z squared, okay? So then the division is very similar to what we did in step 1, so you just, this goes 7, so you can, the constants, you can, the common factors, you can take them out. Then if you check these two, then so I've got a 7, and then when I divide, 5 minus 3 is 2, so x to the 2, 8 minus 4 is 4, so y to the 4, 7 minus 2 is 5, so z to the 5, okay? So let's do another one. Let's say that I have 20 x squared y squared z divided by 4 x cubed y to the 4 z squared, okay? So coefficients, you just take the common factors out, 5, and then x and x, 2 minus 3, that's minus 1, so x to the minus 1, 2 minus 4, so it's x to the minus 2, and remember that's a 1, okay? Z, 1 minus 2, that's minus 1, okay? And generally, in the answers, we do not write with the negative exponents. We always write positive exponents. So you know that when you flip the exponent, then the exponent, the changes its sign, right? We did that in step 1. So you can write that as 5, and then from x to the minus 1, I can bring it down, and then it'll become plus 1, right? If the exponent, the sign changes. Y to the minus 2, when you bring it down, y to the 2. Z to the minus 1, when you bring it down, z to the 1, okay? Then we generally don't write x to the 1, z to the 1 like that. So you can just take that 1 out, so that's the answer. 5 divided by x, y squared, z, okay? So then, the next thing is we want to cover, okay, so we have covered the basic operations, addition, subtraction, multiplication, division. So now we want to do the distribution property thing that we covered before. For example, so let's start with the numbers we know, like 3 times 4 plus 2, okay. So this is 6, so 3 times 6, you know that this is 18, okay. And then the distribution, so I can write this as 3 times 4, I can write that as 3 times 4, plus 3 times 2, right? The distributive property, we did that before. So this is 12, and this is 6, so again this is 18, right? So you can always distribute it 3 times 4 plus 2, you can write it 3 times 4 like that, plus 3 times 2 like that, right? Exact same thing is true with algebra. So for example, I have 3, and then let's say x plus 4, like that, okay? So just like the way we did here, 3 times x plus 3 times 4, 12, okay? So you can treat the variable, the letter x, same as some number, right? So I don't know what it is. So in this case, I know 3 times 4, I put 12. I cannot put that because I don't know what x is. So 3 times x, 3 times x, okay? So that's how you do the distributive property thing like this. And then so let's say I've got 5x times x minus 7. So then you can use the same kind of process, 5x times x, that's 5x squared. 5x times 7, that's 35x, but I have a minus sign, so minus, and then you multiply that 35x, okay? So then you can have a little bit more, complicated things. For example, you can have two expressions. For example, x plus 5 times x plus 7. Okay. So when you have something like this, you use the FOIL method, right? FOIL. So we know how to do that. So you multiply this first, right? And then you multiply that, the second. And then you multiply this, the third. And then you multiply that, the fourth, right? So that's a FOIL method. So x times x, x squared. And then x times 7, 7x. And then 5 times x plus 5x. And then 5 times 7, that's 35, right? So now, if there are any like terms, we need to kind of group them together, right? So here I have 7x and 5x. So it's x squared, I have only one of those. Then if I add these two together, 7 plus 5 is 12, so 12x, and then plus 35, okay? So here, you need to kind of notice something. So when you have like a 5 and 7, and you see the 35 here. So 5 times 7, 35, you get it here, right? And another thing you notice here, I have got 7, I've got 5, 7 plus 7 plus 5, 12, and that's what in the middle, right? So when I multiply these two constants, I get that product here in the constant term. Then when I add these two constants, 7 plus 5, that's what is in the middle, okay? So you just notice that pattern, okay? So then you can use the same FOIL method to do other things. So let me do one more thing. So let's say that I want x plus y times x plus y. So let's say I want to multiply this, okay? So I'm multiplying x plus y by itself, right? So what does that mean? So I can write that as x plus y squared, right? So 5 times 5, I write 5 squared, right? 5 times 5 is 5 squared. Similarly, I write x plus y times x plus y is x plus y whole squared, okay? Then when you use the FOIL method, so you multiply this, and then multiply that, multiply this, multiply this. When you do that, x times x, x squared, and then you get xy, and then plus y times x Again, you need to remember that the order doesn't matter. So whether I write xy or yx, it doesn't matter. Why? Because if I have like a 2 times 4 is same as 4 times 2. 2 times 4 is 8, 4 times 2 is 8. So when I switch the order, it doesn't matter, right? So I can write yx is same as xy, and then plus y squared, and then I can group these two together, right? So this means that I've got a 1 in front of it, I've got a 1 in front of it, 1 plus 1 is 2, so I have 2xy plus y squared, okay? So x plus y the whole squared equal to x squared plus 2y plus y squared, okay? And similarly, if you actually change the sign, instead of x plus y, so let's say I have x minus y squared, so let's say I do that, so then I put a minus sign here, and then I put a minus sign here, so then these two becomes minus, right? So these two becomes minus 1xy minus 1xy. Oh, I'm sorry, I left an x here. And then, so there's a minus, so x squared minus 2xy plus y squared. So before, I had x squared plus 2xy plus y squared, right? When I had x plus y the whole square. Then another important one is if I multiply x plus y times x minus y, if you use the FOIL method, so you do this, and then you do that, and then you do this, you do that. So x times x, x squared, then x times minus y, that's minus xy, y times x, that's same as xy, and then plus y times minus y, that's minus y squared. So these two get cancelled out. 1xy minus 1xy, 1 minus 1 is 0, that's gone. So it is x squared minus y squared. So whenever you have x plus y times x minus y, it's just x squared minus y squared, okay? So this is how, if you want to multiply, expressions, with the multiplication, that's what you actually do. And then we are using the distributive property here, okay? So now we will do the opposite. So we multiply two expressions to get to the product. Now we want to factor expressions, okay? So for example, if you take a number, 56, so you can write that as 8 times 7, right? You can write, 8 is a factor, 7 is a factor, 8 times 7, right? So that's what we mean by factoring 56 is like writing 56 as 8 times 7. Similarly here, the factoring means that let's say I have an expression, x squared plus 2xy plus y squared. So if I want to factor that, so what do I mean by that? I need to write this as something times something, like 8 times 7, right? So just now we did, this equals x plus y times x plus y, right? So whenever I have an expression, if I can write that as x plus something times something, then these two are called the factors. So x plus y and x plus y are factors of this expression here, okay? So similarly, if you just now we did x squared minus y squared, if I want to factor this, we just said that x plus y times x minus y. So before we did the opposite operation, we multiplied the two factors to get to the expression. Now we are doing the opposite. We have an expression. Now I am breaking that down into two factors, right? Okay, so if I have like an x squared minus 49, then using this, so 49 is actually 7 squared, right? Instead of y, I have a 7. So I can plug in, so just plug and play thing I talked about before, right? Y equals 7, so I just need to plug in y equals 7. So you can write this as x plus 7 times x minus 7, okay? So similarly, if we have like an x squared minus 8x plus 16, so then, we've got this is a 4 squared, right? So then we saw the pattern before, just now we did this, like here, we did here. Similarly, with a minus sign, it is, instead of y squared, I have 16, so y is actually 4. So I plug in, so this is actually x minus 4 the whole squared. Or it's x minus 4 times x minus 4, right? So that's how I factor this. So then, so this is how you do the factoring, and then you can actually, after you understand the factoring, you will be able to simplify the rational expressions. So when we have a rational expression, that means that we have something in the numerator, something in the denominator. For example, the first one I've got 2x plus 14, okay, and then divided by 2, okay. So here, what I want to do here is, on the top, I can actually take the common factor out. So between 2 and 14, 2 is the common factor, right? And then, so then the leftover here is just x, 2 times x, right? And then I have taken 2 out, so the leftover is 7. 2 times 7 is 14. So x plus 7. And then on the bottom, I have a 2, okay? Then you can cancel the 2. Then the answer is x plus 7, okay? So whenever you simplify the rational expression, you always need to write that as a, take the common factor out, write it as the product of factors, okay? So let's do another example. So 14x squared plus 8x divided by 2x, okay? So what is the common factor here? So there's an x here, there's an x here. And 8 and 14, 2 is a common factor. So I can take 2x out. Okay, that's a common factor. So the leftover, 14, I've got a 2 times 7 is 14, so I've got leftover is 7. But x squared, I've taken 1x out, the remaining leftover is x, okay? And I've got a plus, put a plus. And then I've taken 2 out, so leftover is 4. 2 times 4 is 8, so I'll have a 4. And then x, I already taken out, so that I don't have any more left over, it's just that. Then divided by 2x. And then 2 and 2 cancel, x and x cancel, so then 7x plus 4, that's the answer. Okay? So you need to be able to factor and then do the simplification when you are dealing with these rational expressions. So let's do another one, for example. So let's say I have 3 times x minus 7, and then plus x times x minus 7, okay, and then the whole thing divided by x minus 7, okay. So what this means is that I'm dividing, so for example, I have a number 10 plus 18 divided by 2. So what does this mean? 10 over 2 plus 18 over 2, right? So that is 5 plus 9, right? So, so when you add 10 plus 18 is 28 divided by 2, that's 14 also. So you can distributive property works in the division like this. So what does this really mean? So this means that, so the first one I'm dividing by x minus 7. This also I divide by x minus 7, exactly like this, right? You know how this works. Similarly, you do the exact same thing here. Then this and this get canceled, this and this gets canceled. So the leftover here is 3, leftover here is x, and that's the answer. Okay? So, so let me do one other, for example. So let's say you've got 5x plus 8, then divided by x plus 6, okay. So here, there are no common factors, so you cannot do 5x over x that equal to 5, you cannot do that, okay. So you have this whole thing on the bottom, the whole thing on the top, so this will not go there, so you cannot simplify that any further. So this is same as what you have written here, right? So it cannot be simplified, okay. So only when you have common factors you can simplify. When you don't have any common factors, you cannot simplify. Okay? So let's move on to the next one. How do we do the addition and subtraction of these rational expressions? Okay. So up to this point, we talked about addition, subtraction of regular expressions of polynomials. But in terms of rational expressions, for example here, so I have a 5x over x plus 2, and then let's say that x over x plus 3, okay? So this is like adding, I've got one ratio or fraction, right? Ratio here, another ratio here, and if the denominators are exactly the same, so if the denominator exactly the same, for example, if I had just this, so then just like the way we did before, if the denominators are the same, we added the two tops, right? That's what we did with the fractions and ratios. Same thing is true. So on the bottom, I have the common denominator x plus 2. Then I add 5x plus x. X means the 1x, right? 5x plus x is 6x. So that'll be the answer. So when you add the two rational expressions, if the denominators are exactly the same, then you just add the two tops, the numerators, okay? But if the denominators are different, so 5x over x plus 2 plus x over x plus 3, so let's say it's that. So then, when we did the ratios before or the fractions, when we started adding the two fractions, what did we do? So we just multiplied, right? Cross multiply, this and this, multiply, this and this multiply. On the top, we added. On the bottom, we just multiplied. Exact same thing you will do here, okay? So on the top, it's 5x times x plus 3. So 5x times x plus 3. And then cross multiply this. So this is x times x plus 2. Then on the bottom, we multiply the 2, right? So x plus 2 times x plus 3. So that's what we did before. It's the exact same thing. Instead of numbers, we have letters. That's the only difference, okay? Now we know how to simplify the top. 5x times x, 5x squared. 5x times 3, that's 15x. Then x times x, x squared. X times 2, that's 2x. Then on the bottom, we have x plus 2 times x plus 3. So now we can simplify, these two are the like terms, and these two are the like terms, right? So 5x squared plus x squared, that means there's a 1 there. So 5x squared plus x squared is 6x squared, right? And then 15x plus 2x is 17x, okay? Then on the bottom, we have x plus 2 times x plus 3. Then if there is any common factor, we want to take it out. On the top, we have x is a common factor, so you can take it out, x, and then the leftover is 6x. And if I've taken out x, so leftover 17, then divided by x plus 2 times x plus 3. So that's the answer, okay? So when the denominator is exactly the same, you just add the two numerators. That's all you need to do. But if the denominators are different, you just cross multiply, and then on the top you'd be adding. If there's a plus here, you'll be adding. If there's a minus, you'll be subtracting. Whatever the sign there, you will do that. On the bottom, you just multiply the two factors here. So the exact same as what we did before, okay? And so that's addition, subtraction is very similar. So instead of a plus, you are going to have a minus sign, okay? So that is same as before. And then the multiplication division is very easy. For example, so let's say I've got x plus 4 over y squared minus 25, and then times, I'm going to multiply y minus 5 divided by x squared plus 5x plus 4. So I'm multiplying. So multiplication is exactly same as before. When we had two fractions or two ratios, what did we do? We multiply the two tops, we multiply the two bottoms. It's exact same thing, no difference, okay? The only difference is whenever you are dealing with the rational expressions, you want to factor them, okay? So here on the top, I have x plus 4. So when you multiply, it's x plus 4 on the top, you multiply the 2, x plus 4 times y minus 5. So that's the top, multiply the two tops, okay? Then at the bottom, you multiply the two bottoms, but then you want to factor them, okay? So y squared minus 25, so this is like a 5 squared, right? So that means that is y plus 5 times y minus 5, right? X plus y times x minus y, x squared minus y squared. We covered that before. So this is how you factor this, y plus 5, y minus 5. And then here, so this is x plus 4 times x plus 1. So you need to factor this. So the two constants, we saw that before. So you need to factor this 4 times 1, the 4 constants, 4 times 1 should multiply to 4. Then when you add the two constants, it should add up to the middle number. So that's what we saw before. So that's how you factor this. So once you do this, so then x plus 4, common factor, you can take them out. And then y minus 5, y minus 5, you can take them out. So on the top, I have nothing, that means that I have 1, right? Just that is, if that nothing means that's 1. And then I have y plus 5 on the bottom. Then I have x plus 1 on the bottom. That's it. Okay? So multiplication means that I'm just multiplying the two top numbers. I'm multiplying the two bottom, instead of numbers, expressions, right? Instead of the numbers, expressions. And then when I multiply, I need to factor them. Put everything in the lowest factor so that I can, the common factors, I can cancel them out. And the division is same as before. So what we did when we did the division for fractions, when you have, for example, when we had 1/2 on the top and divided by 3/4, what did we do? So we did that like a 1/2 times, and then you flip the fraction the bottom 4 times 3. Then it becomes a multiplication problem. Exact same thing you will do here. So if I have to divide, if the division symbol here, so then I flip that fraction, and then it'll be a multiplication problem, okay? So you will do the exact same way that we did now, but except that you just flip it. That's all you need, the bottom one, okay? So now, the importance, so we have covered all these, expressions, rational expressions, and then how do you add, subtract, multiply, divide, we did all those things. So now the next thing we want to do is we want to solve equations, okay? So let's just, so addition, so the expression could be addition, subtraction, or it could be multiplication, division. So let's start with something very simple. So for example, let's say that I have 5 plus 2 is 7. You know that, right? So that's an equation. 5 plus 2 on the left-hand side, 7 on the right-hand side. But if I do 5 plus 2, and then if I subtract minus 2 on the left-hand side, if I do the exact same thing on the right-hand side, then 2 and 2 will get canceled. I have 5 on the left-hand side, 7 minus 2 is 5, right? So whenever I have an equation, right, 5 plus 2 is 7, and then in that equation, if I do minus 2 on the left-hand side, if I do the exact same thing on the right-hand side, then I got another equation, 5 equals 5. Always it'll work, right? So similarly, for example, let's say I have x plus 2 equals 7, okay? So now the goal is, always when we say solve for x, the goal is what is the x value? What is the value of x? So the goal is go after x. You need to do that, right? So now, so if a common sense, if you use it, something plus 2 is 7, what is the something? So the something has to be 5. That common sense, you know how to do that, right? So now, how do we do the, using algebra, exactly how to do that? So remember, the goal is to get, x. So I want to get rid of everything that, nothing to do with x, right? So x plus 2, just like the way we did it here, I've got x plus 2, so then I want to get rid of this plus 2, so I need to do the inverse opposite operation. Instead of plus, I can do x plus 2 and then minus 2. I can do that on the left hand side. If I do minus 2, on the right hand side I have to do the same thing exactly like this I'm doing, right? And then 2 minus 2 is 0, always, that cancel. So I have x on the left hand side, 7 minus 2 is 5, so 5 is the answer, right? So we guessed 5 is the answer, we know that. Something plus 2 is 7, something is 5. But then the way we did that here, I want to have only x, so that means that I want to get rid of this plus 2. How do I get rid of that plus 2? I need to do the operation, opposite of that minus 2. So then I get rid of that. So one way to do this like this. Another way you want to think is, I have x plus 2 is 7, right? So now, once you understand how we get this, so then I want x, I don't want 2, I want to get rid of that. How do I get rid of that? I move it to the other side. When I change side, the sign changes, okay? Changing the side, changing the sign. So I can say that x equals 7, and then plus 2 becomes minus 2, so then that becomes 5. So it's exact same like here, right? So now you understand that. So you can think of it in, multiple different ways. One is, you can always, minus 2, you can do that, minus 2 on both sides and get it this way. Or you can say that I'm going to collect my x, all the x terms on one side, and collect all the numbers on the other side, and I understand that when I switch sides, I switch the sign. So then you get to the exact same answer, okay? So the same thing works for subtraction also. So let's say, for example, I have x minus 2 is 5. So let's say that, okay? Something, I'm taking away 2, I'm getting answer 5. So that something, common sense tells you 7. 7 minus 2 is 5, right? So now how do I do with algebra? So then x minus 2, I have minus 2. I don't want minus 2, I want to get rid of that. So I need to do the opposite. So instead of minus 2, I do plus 2. So I do the opposite, plus 2. And then I have to do the exact same thing to the right hand side. This is gone, so x equals 7, okay? So then that's what we got, okay? So that's one way of doing that. Another way of doing that is x minus 2 is 5. I want only, my goal is to get only x. I want to get rid of, anything else I've got. So this minus 2, I have to take it to the other side. When I change side, sign changes, right? So 5 plus 2, so that is 7, right? So either way you can do that. You can group all the x at one side, all the numbers to the other side, and when you switch sides, you switch signs. If you remember that rule, then you will be able to solve for the value of x, okay? So with addition and subtraction, this is how you solve for x. So let's say that you've got multiplication and division kind of problems, and then how do you solve for x, okay? So let's take a simple example again. So let's say that, I know that 3 times 4 is 12, right? So then, if I divide both sides by 4, right, and then I can cancel this out, I have 3 here, and then 12 divided by 4 is 3, right? So whenever I'm multiplying two numbers, then I divide, if I do the opposite operation on both sides, and I'm going to get the both right and left hand side will be equal, right? For example, I have 3x equals 12. So common sense, you know that 3 times 4 is 12, so x should be 4. So you already know that, right? So let's say how we would do that using algebra. So the 3 times x is 12. So just like the way we did the opposite operation, I want in the addition subtraction, similar thing we'll do here. I want x, but I don't want 3. So 3 times x is there. So I will do the opposite. Instead of 3 times, I will divide by 3. So both sides I'll divide by 3, just like the way we did there, okay? So then this will get canceled, then x, then 12 divided by 3, that is 4, okay? So what we are doing here is that anytime you have a 3 times something, so it's a product instead of addition or subtraction, so then all you have to do is both sides you want to get rid of, so 3x equals 12. So I want only x, I don't want the 3. How do I get rid of that? So it's because it's a product, I need to do the opposite. So both sides I divide by 3. So then I'll have only x on the left hand side. Okay? So that's how you do that. And similarly, when you have a division, for example, so let's say that 24 divided by x equals 6. Okay, so then you want to know what x is. So you know common sense, if I divide 24 divided by 4 is 6. So the answer should be actually 4, right? So now, how do I do this? Okay, so before, so whenever you have 6, it means that's 6 over 1, right? So before we did that, if I have like this ratio equal to this ratio, right, proportion, in step 2 we did that. So then we said that when you cross multiply, and the products are always equal. So when you cross multiply, 6 times x equals 1 times 24, right? So now I will use this multiplication kind of rule. So 6 times x, but I don't like the 6, so I will divide both sides by 6. So then I have x equals 4. So that's what we said before, and that's what exactly we got, okay? So whenever you have a division thing, you can just cross multiply, right? And then you can use this multiplication kind of rule to get to the x value. So that's how you solve for x. So sometimes you will have more terms, in which case you need to simplify the expression first before you can solve for x, okay? So for example here, we have 2x minus 9 minus 5x plus 6x plus 2 equals 5, okay? So then solve for x, okay? So the first thing you want to do is simplify first, right? So you've got the like terms, you've got this term, this term, this term. So 6 minus 5, that's 1. 1 plus 2, 3, so that's 3x, okay? And then you've got this minus 9 plus 2, so that's going to be minus 7, right? So you need to remember step 1, and then equals 5, okay? So then what you want to do is first, you don't want this 3x plus minus 7, right? So you want all the x in one side, all the numbers to the other side, right? So then you don't want this, so you want to move it to the other side. When you change the side, change the sign. So 3x equals 5 plus 7, that becomes 12. So now 3x is 12. What is x? You divide both sides by 3. So x equals 4, okay? So whenever they give you a long expression, then you need to make sure that you take those like terms, simplify that, and then solve, okay? So with another problem, so let's say they're given you a problem like 2 over 3 equals 32 over y, okay? So then it's kind of a little bit difficult to kind of common sense, what is the value of y, it's difficult to see. But you just use the cross multiplication, that's our friend. Whenever you see 2 equal ratios, you cross multiply, that's our best friend, right? So 2 times y equals 3 times 32, so 3 times 32 is 96, so 2y is 96, so then y is, you divide both sides by 2, right? You don't want the 2, you want to get rid of that, so y equals 48. That's the answer, right? So once you understand, so you need to, I may be going too fast for you, so you need to pause and then make sure that you understand and then go do some practice problems. You come back, then it'll make sense to you, okay? So now solving inequalities, so it is exactly same as solving equations with one difference, okay? So when you multiply or divide by a negative number on both sides, inequality gets reversed. Okay, so let's see how that works. So let's say that, so we've got a number line. Now, we talked about that before. I'm going to review that. Okay, so now we know that 2 is less than 3, right? 2 is less than 3, you know that. But then when you put a minus 2, minus 3, so what is the relationship? So this is minus 2, this is minus 3. So minus 2 is greater than minus 3, right? So minus 2 is greater than minus 3, right? So when I multiply both sides by minus 1 in this inequality, inequality gets reversed. Okay, so you need to remember this. We covered that in step 1, okay? So as long as you remember this, you should be able to do the inequalities same way like equations you will do. So let's do, for example, 3x less than 12. So, okay, so similar to what we did before. So you will do the exact same thing like before. I don't like this 3. Both sides I divide by 3. So then I have x, then less than 12 over 3 is 4, x less than 4. That's it. And if the thing is less than or equal to 12, do the same thing, both sides by 3. And then 3 get cancelled, x less than or equal to 4. Okay? Then if the problem is 3x is greater than 12, again both sides divide by 3, then x greater than 4. Okay? And then if 3x is greater than or equal to 12, both sides by 3, then x is greater than or equal to 4. So the solving the inequality is exactly same as before, the way we solved the equation. Instead, equal sign, you have the less than or equal to, or greater than or equal to. Okay, so that's only difference. Okay, so let's do one inequality where you need to change the sign. So for example, we have minus 3x is less than 21, okay? So I want to get rid of this minus 3, right? So I have to divide by minus 3. So whenever I divide by minus 3, so I'm dividing by minus 3 and dividing minus 3, remember the inequality will get reversed, okay? So in this case, minus 3 get cancelled x, then inequality got reversed, 21 over 3, that's minus 7. So x is greater than minus 7, so this is the solution, okay? So you need to remember, whenever you multiply or divide by negative number, the inequality gets reversed, and then we saw why, okay? So then, so now we have solved all these equations. So the next thing we are going to do is solving quadratic equations. Okay. So before we solving quadratic equations, so let's remind ourselves. So if I multiply number 2 by 0, I get 0. Number 10 by 0, I get 0. Right. So any number I'm multiplying by 0, I'm going to get a 0. Right? So any number, it doesn't matter, multiply by 0 means that I'm going to get a 0. Just remember that. So now, let's go to a quadratic equation. So let's say that it's x squared minus 2x minus 3 equal to 0. Okay? So anytime you want to solve a quadratic equation, the first thing you need to do is to factor that quadratic expression. That's the first thing you need to do. So you need to remember the pattern we saw before. So in this case, we have x minus 3. So when you need to factor this minus 3, so 1 and 3 are the only two factors. 1 times minus 3 is minus 3. So then when you multiply these two, you got minus 3. When you add these two constants, you should get the middle number. So that's what we saw before. So same pattern, right? Minus 3 plus 1 is minus 2. So that's how you factor this. And then that equal to 0. And then, so what does this mean? Something times something is 0. So that means that either this number has to be 0 or this number has to be 0, right? So any number times 0 is 0. So we don't know which one is, but one of them has to be 0, right? So that means that x plus 1 equal to 0. So what does that mean? So then I don't want this 1, it has to go to the other side. X equals minus 1. So that's one solution. Or here, x minus 3 equals 0. So I don't like the minus 3, go to the other side. So x equal to 3. So either x could be equal to 3 or x could be equal to minus 1. Those are the two possible solutions for this quadratic equation. So anytime you have a quadratic equation, you will always have two possible solutions. Okay? So that's how you do the solve the quadratic equations. Okay? So now, so we have covered a lot of material at this point. So let's do some practice problems. Put all the material together and do some practice problems. Okay? So let's do. There are 12 practice problems. So go to the booklet, and then there are 12 practice problems here. So let's do those, okay? So the first problem here, it says that solve for x, okay? So you need to solve for x. And it says 3x plus 5 minus 8x minus 9 equals 16, okay? So the first thing you need to do is simplify, right? So 3x minus 8x, right? So minus 8 plus 3 minus 5x. And then you need to combine minus 9 plus 5, so that's minus 4, equals 16, okay? So now, I don't want this 4 here, so you're going to take the other side and switch a sign, right? So minus 5x equals 16 plus 4, that's 20. And then now I don't want this minus x, so divide both sides by minus 5. And it's an equality, equal sign, so I don't need to worry about any changing inequality. So on the left hand side I've got x, right hand side I've got minus 4, that's the answer. Okay? So the second problem is solving the quadratic equation, okay? So the second problem is x squared plus 3x minus 40 equals 0. So we saw how to do that before, we saw the pattern, so we need to actually factor that, right? So 5 times 8 is 40, so minus 40. So what you need to do is, you need to find out, two constants. And if you take like a plus 8 and then minus 5, so 8 times minus 5 is minus 40. So the two numbers the product should be equal to that number with the sign. And then when you take the 8 minus 5 is plus 3, you have that in the middle. So that's how you factor that. So that equal to 0. So that means that either x plus 8 is 0 or x minus 5 is 0. So that means that either x equal to minus 8 or x equal to 5. Right? So that's the answer. So, so we have done, a couple problems where we solve the value of x. And in the test, they usually give you problems where you don't have to solve all the way, but you need to do the expressions. For example, problem number 3, it says that Team A ordered baseball caps, each cap costing X dollars, okay? Team B's cap was $3 more than Team A's cap, okay? So that means that Team A is X, X plus $3 is the Team B's. That's what that means, right? So Team B spent $200 to buy caps for all their players. How many players are there? So first, you need to think through the problem. So if Team B spent $200 to buy caps, so if $200, that's what they spent, and then if you divide that by the number of, so the $200, right? And if you divide that by, if each cap costs $10, right? So just remember, 200 divided by 10 caps, the $10, so 200 divided by $10 would be 20. So they bought 20 caps. So that's how you would know, if you know the numbers. But here I don't know the numbers. I don't know what is the price of each cap. So first you need to frame the problem. I've got $200. If I had, $10 a piece, 200 divided by 10, that will give me the number of players. So it's a division problem. And then I don't know the price, but the price is x plus 3. So the answer is 200 divided by x plus 3, right? So they ask you problems like that in the test, so you need to know exactly how to do this. So the next one is solve the inequality. So problem number 4, 4x plus 9 minus 7x plus 12 less than 6. So you first simplify, take these two, minus 7 plus 4, that's minus 3x. And then 12 plus 9, that is 21 less than 6. Okay? So then I don't like 21, I need to move it to the other side. Okay? So then when I'm moving, I don't have to change the sign, right? I mean, only when I multiply divide by minus, negative, then I need to reverse the inequality. But when I move, I don't have to do anything with inequality. It's the same as before, just keep the less than. And then 21, 6 minus 21, that's minus 15. So now I don't want minus 3, so I need to divide both sides by minus 3. So now, since I'm dividing by a negative number, then the inequality gets reversed, okay? So on the left-hand side, I've got x, and inequality gets reversed, and then that is 5. So x is greater than 5, okay? So the next problem, so let's erase this before we do the next problem. Okay, problem number 5. 8b to the 4, and then we have a squared plus 7ab plus 8c squared. Okay, so just simplify. So all you have to do is multiply distributive property, remember, so 8b to the 4 times a squared, so 8 times b to the 4 times a squared, plus multiply this with the second term, 7 times 8 is 56, then a times a is just a, b times b to the 4, right, so b to the 5, 2 exponents, add the 2 exponents, remember, that's b to the 1, right, and then plus 8 times 8, that is 64, then I have b to the 4, and then I've got c squared, that's it, okay. So the next one problem is a rational expression. So on the numerator, on the top we have 45 x to the 5 minus 54 x cubed y cubed plus 81 x squared y minus 36 x squared, and the whole thing divided by 9 x squared. Okay? So the whole thing means that every one of these terms is divided by that, right? So for example, if I have, let's say I've got 10 minus 2, and then divided by 2, let's say that. So this means that 10 over 2 minus 2 over 2, that's what that means, right? So that's 5 minus 1, that's 4. So when we do the division like this, so the bottom thing, so under every term, you are going to have the denominator, right? So you need to remember that. So what this means is that every one of these 9x squared, so you can put the 9x squared, put the 9x squared, put the 9x squared, put the 9x squared. That's what that means, okay? So then it's easier to do that. So then you can common factor, this and that, it'll go 5 times, and then 5 minus 2 is 3, so x cubed, and then 54, 9, that's 6 times 9 is 54, and then x cubed, x squared, so that's going to be x to the 3 minus 2 is 1, and then y cubed, there's nothing on the bottom, so you just leave that alone, and then plus 81 over 9, that's 9, x squared, that gets canceled, right? So this goes like a 9 times, this goes like a 6 times, right? So then, so this went 5 times. So then here, 9 times y, then minus, this goes 4 times, so you have 4, x squared gone, so that's it. So you don't write x to the 1, you just write x, okay? So that's how you do that. Then let's do problem number 7. It's another, so this rational expression is very easy. You put it like this, you are done. And sometimes they may give you a little bit more complicated expression on the bottom. So then, in which case you need to know exactly how to do that. So problem number 7, so it's 7a squared times 2a plus b, then minus 2a plus b the whole squared times a minus b, and then minus ab times 2a plus b. The whole thing, so as we said before, I'm going to split that. So the first one, and then on the bottom, you have 2a plus b. So 2a plus b, here you have 2a plus b, here you have 2a plus b. Okay, so the rational expression, the whole thing divided by the whole thing 2a plus b, just like the way in the previous problem we did, so it'll be easier for you to write the divisor under each term like this. So then this way, you can cancel the common factors just like that. So 2a plus b, it'll go to one of those. It'll take one thing out, right? And then this will go. So then, so this is 7a squared, that's a leftover from here. And then here, the leftover is 2, and then 2a plus b times a minus b. So one of them is gone, one is left. Then the last one I've got ab, right? So then after that, then you need to now simplify, right? So then you need to multiply 7a squared, and then you need to multiply this 2 times 2a times a is 2a squared, so it's 4a squared. And then 2 times 2, 4a, and then minus b, so that'll make a 4ab. And then the FOIL thing, like the b times a, 2ba minus 2ab. And then b times b squared minus, so plus 2b squared, and then minus ab, okay? So then you need to kind of, the like terms, you need to group them together. You've got this, and then you've got that. So when you do this, you get 3a squared, and then ab plus 4 minus 2 minus 1, so that's ab. Then you've got 2b squared, okay? So that'll be the answer. Okay, so you need to simplify in the end. So it looks kind of complicated, but once you start practicing problems, you should be fine. So the next problem is another one, where you actually don't need to solve it, but you need to know how to actually set it up. Okay, so problem number 8 says Adam has 6 C books for every book that Bob has, and Kathy has 8 D books, which is 20 more than Bob has. How many books does Adam have? Okay, so first let's look at Kathy. Kathy has got 8 D books. Okay, she has got 8 D books. That is 20 more than Bob. Okay, so she has 8 D. She has 20 more than Bob. So if I take minus 20, so this is how many Bob has, right? So Kathy has got 8 D. If I subtract 20, that's going to be how many books Bob has, okay? So this is how many books Bob has. So you need to do that first, that part. And then if you read the first sentence, Adam has 6 C books for every book that Bob has. If Bob has 1 book, Adam is going to have 6 C books, right? So if Bob has 8D minus 20, so then Adam is going to have 6C times 8D minus 20. So that's the answer. Okay? So you multiply for every book Bob has, he has got 6C. So if he has 8D minus 20, it times 6C. So that many books. Okay? So then the next one, problem number 9. What is the value of x squared plus 5y and then times 3y minus 6z if x equals 2, y equals 4, z equals 5. Okay, so this is an easy problem. All you have to do is plug in, right? Instead of x, you plug in 2. Instead of y, you plug in 4. Instead of z, you plug in 5. Right? You just plug in, plug in, plug in. So 2 squared is 4. Then 5 times 4 is 20. Then 3 times 4 is 12. 6 times 5 is 30. Right? So it's a 24 times 12 minus 30 is minus 18. So 24 times minus 18 is minus 432. Okay? So these problems are very easy. They may look complicated, but you just need to plug in the numbers. That's all you need to do. Okay? So let's do problem number 10. It says that if there are X stores, and if each store has Y computers, and if each computer has 2 monitors, how many total monitors are there? Okay? So got X stores and each one of them got Y computers, right? But X stores and then each one has got Y, so that means that X times Y computers, right? So that's the first thing, it's a product, X times Y. And then that many computers, but each computer has got 2 monitors, so that means that 2 times XY, that many monitors are there, okay? So now let's do the next one, and the next one is it's like a puzzle. The figure is a multiplication box. Each box represents a horizontal number, represents the product of the horizontal number and by the vertical number, okay? So let's write down that table here. So what they are saying here is I've got a table. So this is 7 and X and then 5. And then I've got 2 and then Y and 3. And 14 is here. This is B. This is 10. This is 18. This is D. This is A. This is 21. Okay? So what they are saying here is if you multiply, so this is problem number 11. So what they are saying is that 2 times 7 is 14, right? And similarly 3 times 7 is 21, right? So like that, so everything here is the product here, okay? So now it's just like, solving the puzzle. So the B, 3 times 5, 15. So B is 15. You can easily figure it out, right? So now 10, like a Y times 5, 5Y is 10, right? 5 times something is 10. So 5 times 2 is 10. So Y is 2. So you figure that out, okay? So once you know that Y is 2, then A is 2 times 7 is 14. So A is 14. Okay? So then, so we've got all these. And then here you've got 18. So 3 times X is 18. Right? So 3 times something is 18. What is that something? 6. 3 times 6 is 18. So X is actually 6. Right? So once I know that, so then D is what? 6 times 2 is 12. Right? So you just need to, like the puzzle, crossword puzzle, you just need to put it. So now the question they are asking, AD. So what is the value of A times D? So A is 14 and D is 12. 14 times 12 is 168. Okay? And then problem number 12, they are asking what is A minus B. So A minus B, so A is 14, B is minus 15, so A minus B is minus 1. Okay? So this problem, you need to make sure that you understand the problem. So you just take this times this, 2 times 7 is 14. So that's what they mean. So then you need to fill out the numbers as much as possible, and then you answer the question. Okay? So now what I'm going to do is that there are a lot of applications, of all the materials we've covered so far. So I am going to do some of those application problems, okay? So it's a little bit different than what we have done so far. So the next page here, I've got about 7 application problems. I'm going to go through those. So the first problem, application problem here, says Anne has got 14 coins in quarters and dimes. So you don't know how many quarters, you don't know how many dimes. Totally, she has got 14. And it's worth $2.30. How many coins of each she has? Okay? So the way you set it up, in a lot of times in the test they ask you, they want to make sure that you are able to set it up. So, so let's say that, the quarters and dimes, so she's got, Q is the number of quarters, D is the number of dimes, okay? So number of quarters plus number of dimes, the number of coins, right? She's got 14 coins. So you first write down the number of quarters is Q, number of dimes is D, so Q plus D is 14. That's one equation. And then they are saying it's worth the $2.30, okay? So you can write this in 2 ways. So either you can say each quarter, what is the value of each quarter? 25 cents. So if I say 25 times Q, so that will be the value of all the quarters in terms of cents. Similarly, each dime is worth 10 cents. So 10 times D is going to give me the value of those dimes in terms of cents. And that equal to, they say, $2.30, but I'm doing everything here in terms of cents. So $2.30 means that 230 cents. So 230 cents, right? So those are the 2 equations. So you've got 2 variables here, unknowns, number of quarters, number of dimes, and you've got 2 equations. So another way, if this doesn't make sense to you, another way to write the same equation, so $2.30, so that means that everything you want to write in terms of dollars. So instead of a 25Q, you could have written 0.25 times Q, right? So every quarter is worth $0.25, so 0.25 times Q. Similarly, every dime is 0.10, right? 10% or 0.1. So you could have written 0.10, that's the value, right, in terms of dollars. And then you could have written 2.30, $2.30. So it means the same thing. You could have written in terms of $0.25, $0.10, $2.3, or you could have written everything 25 cents, 10 cents, 230 cents. Okay? So this much you need to know how to set it up, because there are some questions where they ask you to set it up like this. Okay? So the number of coins is one equation, the value is another equation. So then if you want to solve it, how many quarters, right? So then we use a method called substitution method. Substitution method, okay? So what that means is that, so I have 2 unknowns here, like Q and D, so I don't know how to solve it. But if I have only one unknown, just one X or one unknown, I know how to solve it. That's what we have been doing so far, right? So then how do I get rid of the, one of these? So from the first equation, q plus d is 14. So then what I can do is, so I can, from here, I can write d equals, I can get rid of this q, it can go to the other side, it becomes 14 minus q, right? I can take it to the other side. So then in this equation, I substitute. So I've got 25q, and then plus 10, instead of a d, I will substitute 14 minus q. That's why it's called substitution method. Then I still have 230. So I'm just rewriting this equation, and instead of a d, I'm substituting the value of d from the first equation. Now I know how to solve it. So now I can simplify. So 25q, then 10 times 14 is 140. 10 times minus q is minus 10q. Then that equals 230. So then I can lump these two together. 25 minus 10, that's 15q. And then plus this 140 equals 230. Now I know how to solve this. I don't want this 140, I want to get rid of that. I want to take it to the other side. So 15q will be equal to 230 minus 140. So that'll be equal to 90, right? So now 15q is 90, so what is q? So I divide both sides by 15. So then on the left hand side I get q. On the right hand side, 90 divided by 15, I get 6. So q equals 6, that means that n has got 6 quarters. So this is 6 quarters. So how many dimes? 6 quarters, how many dimes? This is, total is 14, so this has to be 8. So she's got 6 quarters and 8 dimes, so that if you add that up, it'll add up to $2.30. Okay? So that's one of the applications. And so let's do another application problem. So the second one is dealing with the team. A team won 3 times as many games as they lost. If they played 48 games, how many did they win? Okay. So the second problem, it says that if they won 3 times as many games as they lost, right? So if they lost L games, 3 times L, that many games they actually won. So the first step is writing down this equation is the first step. Number of wins W equals 3 times the number of losses, 3L. That's the first step. So then they are saying they played 48 games. So that means that, so the number of wins plus the number of losses, however many, so that should be equal to 48, right? 48 games means some of them they won, some of them they lost. When you add the two together, you should get 48. That is, you need to be thinking about that, right? How the 48 games are total. So number of wins plus the number of losses, 48. You need to do that, okay? So now, again, the substitution method, I've got 2 unknowns, W and L. So we know that W equals 3L, so I can substitute. So 3L plus L equals 48. So 3L plus 1L is 4L, right? 4L is 48. So then I don't like the 4, I divide by 4 both sides. So L equals 12. So that means that they have 20 losses. So how many wins? So 3 times that. So the number of wins is going to be 36. So 36 plus 12, you get 48 total, right? So they had 36 wins and 12 losses. Okay? So this is a nice application of how you do the solving, right? Okay, so now let's do the next problem. So let me do it here. Problem number 3 says sum of 3 consecutive even numbers is 126. What are the numbers? Okay? Okay, so even numbers means that, so let's say I've got a number, so 2, let's say 2x is an even number. How do I construct an even number? So even number, if I just say x, there's no way I can say that it's an even number, right? X, I don't know what it is. So 2x will be one even number. And then when it says consecutive, so then 2x, then plus 2 will be the next even number. And then 2x plus 4 will be the next even number. So for example, in order for you to see this, so let's say I have 8 is an even number. So 2 times 4 is 8. And then 8 plus 2, 10 is the next even number. And then 8 plus 4, 12 is the next even number, right? So you need to set it up in such a way that I've got a 2x, I've got 2x plus 2, 2x plus 4. Those are 3 consecutive even numbers, okay? And it's saying that the sum of them is 126. So that means that 2x plus 2x plus 2 plus 2x plus 4, if I add them up, it's 126. So now if I group them, so that's 6x, and then if I group them, plus 6 equals 126, okay? So now I don't like the 6 here, so 6x, I take the 6 to the other side, so 126 minus 6, that's 120. So then x equals, I don't like 6, both sides I divide, so then it is 20. So x is 20, okay? So if I go back, so then 2 times 20, this is 40, then this is 42, and this is 44. So when you add these three numbers, you do get 126, okay? So whenever they say that 3 consecutive even numbers, you always want to set it up as 2x is the one number, 2x plus 2 is the next number, 2x plus 4 is the next number. But if they say that 3 consecutive numbers, in that case, you can start with x, and then x plus 1, x plus 2, like that. But the moment they say even numbers, you should always do 2x, 2x plus 2, 2x plus 4. Like that, you need to set it up, okay? So, next problem, let's do the next application. So this is problem number 4. So it says that Anne is twice as old as Cindy. 8 years ago, Anne was 4 times as old as Cindy. How old is Anne? Okay. So currently, so just let's talk about today. Anne is twice as old as Cindy. Okay. So if we take Anne's age is A, 2 times Cindy's age, 2 times C. That's Anne's age today. So 8 years ago, Anne was, so today's age is A minus 8. So this would have been the age 8 years ago for Anne. Then it says that Anne was 4 times as old as Cindy at that time. So 4 times, Cindy would have been C minus 8 years old at that time, 8 years ago, right? So that's how it is. So now, just the substitution method, there are 2 unknowns, A and C. So the substitution method we talked about, A equals 2C. So I can just substitute 2C, then minus 8, 4 times C. 4 times minus 8 is 32, right? So then I can bring all the letters in one side, all the numbers to the other side. So I can move this 2C to this side, so it becomes 4C minus 2C, sign changes. And then this number, I'm moving it over here. So minus 32 will become 32, and then I already have minus 8 right here, right? So on the right-hand side, I have 2C. On the left-hand side, I have 24. So I divide both sides by 2. So C equals 12, okay? So that means that Cindy is 12 years today, okay? Cindy is 12 today. And so Anne is 2 times that, so Anne is 24 years today. So Cindy is 12 today and Anne is 24 today. Okay, so that's how you solve that. Okay, so these are, little complicated kind of problems, but sometimes they do ask these kind of questions in the test. So I want to go over that, so you may have to pause and, re-watch this a few times for you to get an understanding. okay? So the next problem, problem number 5, 40 adults and children together went to a museum and paid $560. Adult ticket is $30, children's ticket was $10. How many children were there? Okay, so the number of adults plus the number of children together is 40. 40 people together, adults and children, okay? And then it says that adult ticket is $30, so each one of these A people would have paid 30, right? 30 times A. Each child would have been paid $10, so this is 10 times C. This is how much the children would have paid. Together, the total money, they are saying $560. So this is the hardest part, when you read this problem, setting these two equations up will be the hardest thing. So the way you need to think, let me first write down adults plus children is 40. And then adult is paying $30 per adult, so 30 times A is the total money. 10 times C is the total money the children paid. Together is $560. So that's the way you should be thinking, okay? So then the substitution, method we talked about before, so you can actually do that. So from the first here, A plus C is 40. So then you can say that C, so you want to take the A to the other side. So then C is equal to 40 minus A, right? So now here I can substitute is 30A, and then 10, instead of C, I put 40 minus A, I'm substituting, equal to 560. So now I can simplify 30A, and then 10 times 40, 400. 10 times A, that's minus 10A, that's 560. Then I need to combine the two A's. 30 minus 10, that's 20A, plus 400 equals 560. So now I don't want the 400 here, I want to get rid of it to the other side. So 20A equals 560 minus 400, that's 160. So now 20A is 160, so what is A? I divide both sides by 20. So this gets canceled, I get A. Right hand side, that it goes 8 times, so A equals 8. So I've got 8 adults, so this A is 8. So 8 adults plus children is 40. So the children is 32, right? So 8 adults and 32 children. Okay? So let's do the next one. So next one is, it involves geometry, so which we haven't covered so far, but you must have read the geometry in the book already. So let's say that I've got this rectangle, okay, and then the area of this rectangle is 48 square feet. This is the area, right? So the whole square area here, 48 square foot. And then the width, I don't know what the width is, but the length is 3 times the width, okay? So now the question they are asking, what is the width? Okay, so what is the width of this rectangle thing? So the area of a rectangle is always the length times the width. So in this case, the length times the width, that's the area, okay? So in this case, the length is 3W times, the width is W, right? So 3 times W, that is 3W squared. So that is the area. That area equal to 48. So we've got this equation here, 3W squared is 48. So I don't want the 3, I divide by 3, So this gets canceled, so I have W squared equals 48 over 3, that's 16. Okay? So now, so what we got is W squared equal to 16. So W times W is 16, that's what that means, okay? So then W is 4 times 4 is 16, right? So W is square root of 16, that's 4. So you do not want to make a mistake. W equals 16 over 2, that's not right. W squared, so W times W is 16. So you know that 4 times 4 is 16. So you need to take the square root of 16, that's 4. So it is not 16 by 2. You need to remember that. So W is 4. So that means that in this rectangle, so this is 4, this width is 4, and 3 times that, so this is 12, that's a length. So you know that 4 times 12 is 48. Okay? So you need to make sure that when W squared is 16, you take the square root of 16 to get the W. Okay? So then the next application problem, so last one. So here, total weight of 3 boxes is 45 pounds. The first box weighs 3 times as many as the second one. Third one weighs 5 times as the second one. What is the weight of the third box? Okay. So we've got 3 boxes. Okay. So the first box weighs 3 times as many as the second one. So I don't know what the second one is. Let's call it X. So the first one 3 times as the second one. So the first one is going to be 3X. And then it says the third one weighs 5 times as the second one. So 5 times X. Okay, so those are the weights. Now the total weight is 45 pounds. So if I add up all these weights, that is 45 pounds. Okay, so 5 plus 3 is 8. This is 1. Remember, there's a 1, 9x. So 9x equals 45, right? So x equals, so you divide both sides by 9, so that's 5. X equals 5. So the 3 boxes now, so the first box is, so 3 times x, that's 15 pounds. Second box is 5 pounds. Third box is 5 times 5, 25 pounds. So now when you add all these, you get 45 pounds. So the question is, what is the weight of the third box? And that is 25 pounds. Okay? So setting these problems are the hard ones. Okay? So once you practice, you will be able to get it. So the last thing is, find the next slide, finding patterns. So, for example, they may give you a sequence like this, 1, 6, 11, 16, and then 26. So they will ask you to find out, what is the missing number in the sequence, okay? So you need to be looking for the patterns, you always look for, so 1, and then if you add 5, you get a 6. 6, and then you add a 5, you get 11. 11, and then you add a 5, you get 16. And then 16, you add a 5, you are going to get 21. And then 21, and then you add a 5, you get 26. So the missing number is 26. So you just need to look for the pattern, okay? And let's just do another one. So let's say we've got 8, and then 11, and 14, and 17, and then 23. So again, you look for the pattern, 8, 11, so 8 plus 3 is 11, 11 plus 3 is 14, 14 plus 3 is 17, 17 plus 3 is 20, and then 20 plus 3 is 23, so the missing number is 20. So these, the patterns, these are the very easy one, for you to figure out, okay? So far we have covered the most of the algebra thing. The next topic we are going to cover is the equations of the lines, okay? So we will do that in the next session. Okay, in this session we are going to cover functions, equations, and coordinate geometry. So let's just look at this picture here. We've got 4 quadrants. Quadrant 1, 2, 3, 4. Got x-axis, y-axis. And right in the center we have origin, 0, 0. So from origin, you go right, and then the x, so the x values keeps going up. If you go left, x values keep going down. Then from the origin, you go up, the y values keep going up. And then from the origin, you go down, the y values going down, okay? And these are called the 4 quadrants, okay? So now let's move on to the next slide. In this coordinate geometry, we've got like a graph paper, we've got the origin that's in the center. And then we can actually plot points. For example, I want to plot a point 2, 3. Let's say that. So then it's called ordered pair x, y, 2, 3. So what that means is from the origin you go 2 units to the right. So that's a x equals 2. So along the x direction you go 2 units. And then ordered pair y equals 3. So then along the y direction you go 3 units up. And that point is 2, 3, okay? So let's look at this point, minus 3, 1. So then from the origin, you can actually go, because it's minus 3, you are going on the left 3 units, and then y equals 1, so you go up 1 unit, okay? So either you can go up and then go across, or you can go across and then go up. That's okay. Either way you can go from the origin, but the key thing is ordered pair means that x is minus 3, y is 1. So you need to remember that all the time. So and then let's say the point minus 1.5 minus 2.5, that means that from the origin it's minus 1.5x. So on the x direction left you go minus 1.5, and then you go down 2.5 in the y direction. Minus 2.5 means you are going, y means that you are going down 2.5, okay? And then you got a point 3, minus 2. So that means that from the origin you go 3 units on the right hand side because x equals 3. And then y equals minus 2. So you come down 2 units, okay? So as you can see, on the first quadrant, both x and y, both are positive. On the second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. Fourth quadrant, x is positive, y is negative. Okay? So now, so you have a fairly good idea of how to draw points. Okay. Now let's say that I've got a point in this graph paper, I've got a point, and then I can draw any number of lines through that point, right? So I've got the dark blue line, the light blue line, red line, green line, any number of lines I can put through a single point, okay? So that's just interesting, thing you want to know. But on the other hand, let's say I've got 2 points, minus 2, minus 1, 4, 3, I've got 2 points. So with 2 points, if you take your ruler and then draw a line through these 2 points, you can draw exactly one line, only one line, right? With 2 points, you can draw only one line. So anytime you want to draw a line, if someone gives you 2 points, then you can draw exactly one line through those 2 points, okay? So now, let's say that here I've got this line. I've got a line with 2 points, but it doesn't mean that the line has got only those 2 points. There are so many other points on the line, right? I'm showing a lot of these other little blue points here. There are so many blue points on the line. It's not just the 2 points, right? And so that means that for example, so let's say this point on the line, 4, 3, so that means that this x coordinate, this x distance for that point is exactly 4, right? So then from that point, if I just go across, and then that value, the y value is 3, right? So that's what that means. So from the origin, this point, x value is 4, but from the origin, the y value is 3. For any when x equal to 4, y equal to 3. That's what that means, right? When x equals 4, y equals exactly 3. Similarly, if I want to know when x equal to 3, what is y? All I have to do is, when x equal to 3, I draw this arrow up, I go to the line. From that point, I go across, and then whatever the value here, that is the y value, right? Similarly, when x equals 2, then if I want to know what is the value of y, I just go up, this is the point, and I go across, that's the value of y. Any x value, if from x value here, I go up, I go across, right? Similarly here, when x equals minus 2, I put a line and then go across, that is minus 1. If when x equal to minus 3, I just go down, go across, I get the value of y, right? So what this is there are so many points on the line. For any x value, I can find the corresponding y value. So I've got a point on the line, and then that gives me the x value, and then if I go across, that gives me the y value. So this line is actually represents a relationship between x and y. Okay, so the relationship. And sometimes we call the relationship as a function. So that means y is a function of x. Okay, y equals f of x. And that function, this line I have drawn here, there is an equation that represents the line. So this line, you can call it a function, you can call it a relationship between x and y, or there is a equation that represents this function. Okay. So now let's see how we can write the equation to this function. So you are familiar with this rise over run. So let's say I've got a point x1, y1. I've got a point x2, y2. I've got 2 points, right? With 2 points, we know that exactly there is one line, right? We've got that. So then that line could be, it could be like this, it could be like that. So the line could be any slanted line. The slanting, it can be shallow, it could be more slanted, more slanted, more slanted, it could be any shape. So we want to know how slanting this line is. And then, so there is a measure that's called the slope. The slope tells me how much this line is slanted. And that slope is called rise over run, okay? So let's just take this example here. So I've got a point x1, y1, which is 2, 1. Then I've got a point x2, y2, let's call it 4, 4. And then the way we define the slantness of the line, the slope of the line, it's rise over run. So that means that the delta y versus delta x. So that is y2 minus y1, which is 3, divided by x2 minus x1, which is 2, 3 over 2. So the slope for this line is 3 over 2. So 3 over 2 tells me how slanted this line is, okay? So that is one way I can kind of define or characterize this, this function, right? Okay. But then let's look at the 2 lines. I've got blue line, black line. I've got 2 lines. If you look at the rise over run for both lines is actually 2 over 1, 2, right? But then the 2 lines are 2 different lines. So the line, I cannot just characterize or describe or define that line just by the slope. I also need to see where that line is located, where it is meeting the y-axis. So in this case, this black line cutting the y-axis at 2, the blue line cutting the y-axis at -1, right? So I've got 2 things. One is where it's cutting the y-axis is one thing. Other thing is how slanting the line is. So there are 2 characteristics or 2 definitions I can use to describe this equation or function, okay? So far, I talked about the slopes, and then in all the examples we saw positive slope. But there could be negative slope. So this line is kind of, instead of going up, it's coming down. And this line, it cuts the y-axis, here at 0, 2. Okay. So that intercept is actually, y-intercept is actually 2. And then that line is cutting the x-axis at 4, 0. So x-intercept is 4, y-intercept is 2. And then this line is kind of slanting down. Instead of slanting up, going up, it's actually going down. And you can actually, by looking at the line, you can see what the y-intercept is, where it's cutting the y-axis, where it's cutting the x-axis. You will be able to see that when you look at this line, right? So now let's put all the pieces together here. So the way we describe this equation or the relationship or the function, they all mean the same thing. We call it a standard form. Standard form, the way that's written, y equals m max plus b. Okay, so m is the slope, b is the y-intercept. Okay, so m is the slope, b is the y-intercept. So that is called the standard form. That's the way we describe this line. Okay, so let's look at this blue line here. In the blue line, if you look at the slope here, it is 3 over 1. Rise over run is 3 over 1. So slope is 3. Look at the intercept where it's cutting the y-axis exactly at minus 3. So the intercept is minus 3. Slope is 3. So now you just need to remember in algebra, plug in, right? So y equals mx plus b. M in this example, the blue line is 3. Slope is 3. So you put 3. And intercept is minus 3. Plug in b equal to minus 3. So you can write the equation y equals 3x minus 3. Okay? So that's the equation to that line. Okay? So let's just look at another line. On the right hand side, we've got a blue line. And if you look at the rise over run, it is rise is 1, run is 2, 1 over 2 is the slope. Intercept is 1. So if you write down the equation in the standard form, y equals mx plus b, m plug in equal to 1/2, b plug in 1. So y equals 1/2 x plus 1. Okay? So that equation y equals mx plus b, it describes the function or the relationship or the equation to a line. Okay? Where m is the slope, b is the intercept. And you can notice that the slope is 1/2, it's small, so it's a shallow line. When slope is 3, slope is bigger, it's a steeper slope, right? So the slope is getting bigger, then the line is going to get steeper. Okay? So now, so this is the line we saw before. The slope in this case is negative. So, right? So far we talked about the positive slope. It's getting steeper. Now, this line is actually, instead of going up, it's coming down, like a slide is coming down. So in that case, the slope is actually, it's minus 1/2. So when the slope is negative, then the line is going down. When the slope is positive, the line will be going up. Okay? Okay, so now let's put it all together. So in this picture, when m equals 0, slope is 0, it's actually horizontal line. The green line here, horizontal line, means that the slope is exactly 0. And then the light blue line, m equals 1, when slope equals 1, it's a 45-degree line. It's that slope. But m equals 10, so the higher the slope, you see the dark blue line is much steeper. Much steeper line. And then when negative slope, when m equals minus 1, you see this light red line, it's going down instead of going up, going down with minus 1. But the dark red line, you see m equals minus 10. So when you've got a minus a large number, that means that the line is steep. It's a negative slope. It's going down, but it's much steeper. Okay? So now you have an idea what that the line, the equation actually means. So now let's look at this blue line here. Okay. So the equation to the blue line is y equals 3x plus 1. Okay. So now if you look at the slope, so how do you exactly do a slope? So you need to understand that. So in order to define the slope, rise over run, you always start a point on the line. Okay. And then you need to end up at another point on the line. So you need to pick 2 points on the line. That's very, very important, on the line. And then you take 1 point and then you go across and then you go up. Okay. So if you go across 1 unit and then you are going up 3 units here, the slope is 3. Okay. So whenever you measure the slope, remember, so you always start 1 point on the line, go across, go up, you need to end up at another point on the line. That gives you the slope, right? So in this example, the slope is exactly 3. And then you look at the intercept. The intercept, it's this blue line carrying the y-axis exactly at 1, okay? So the y-intercept is exactly 1, that equal to b, right? And then the slope is 3, that is equal to m, okay? So the equation is y equals mx plus b, and then just plug in. So m equals 3, b equals 1, so y equals 3x plus 1, right? So if you know the slope, if you know the intercept, if someone gives you the blue line, you will be able to measure the slope yourself, just the 2 red points. You need to draw the 2 red points yourself and then find out the slope, and then you will be able to see the intercept where it's meeting the y-axis. So then once you can figure out the slope, figure out the intercept, you can write down the equation yourself, okay? So now let's look at another example. So the same line, I've got y equals 3x plus 1, the same line. So now I've got 2 questions. So the question is, does the point 3, 2, ordered pair 3, 2, does this point lie on the line? Yes or no? I want that answer. Second question, this point minus 1, minus 2, does this point lie on the line? Yes or no? Okay. So it's very easy. When you look at the picture, right, the point 3, 2, it does not lie on the line, you know. So you'll say, duh, it's so obvious, right? It does not lie on the line. The point minus 1, minus 2 lies on the line. It's very obvious, right? But then if I ask you the ordered pair 100, x equal to 100, y equals 50, that point, does it lie on the line? You won't be able to answer that because that 150, it's not in the graph here. You will not be able to do that. So there must be another way to figure it out, okay? So now let's see how we can do that, okay? So let's go to the first question. Does 3, 2 lie on the line? So the key is, again, plug in the ordered pair 3, 2 in the equation, okay? So when x equal to 3, y equal to 2, plug it in the equation y equals 3x plus 1, okay? So now y equal to 2, plug it in, x equal to 3, okay? Now, is it equal? On the left-hand side, you've got 2, right-hand side, you've got 10. Are they equal? No, they are not equal. That means that 3, 2 does not lie on the line, okay? So if I give you a point 100, 50, does it lie on the line? All you have to do is plug in x equal to 100, y equal to 50, plug it in here. Are they the right hand side equal to left hand side? If they are equal, yes, it lies on the line. If they are not equal, no, it does not lie on the line, okay? So similarly here, does minus 1, minus 2 lie on the line? So you need to plug in minus 1, minus 2 in the equation. So that means that you are plugging in y equal to minus 2. You are plugging in right here. X equal to minus 1. Plug it in here. Okay. Yes, they are equal. Now, yes, this point, minus 1, minus 2, exactly lies on the line. That's what you are able to see that here, right? So that's how, if the question is, does this point lie on the line? All you need to do is just plug it in and see whether the two sides are equal. If they are equal, yes, it lies on the line. If they are not equal, no, it does not lie on the line. Okay? Okay. So now you've got a line here and they've given an equation x plus 2y equals 7. And you see that it's not in the standard form. So it is not like y equals mx plus b. So if someone asks you, hey, what is the slope of the intercept of the line? It's very difficult. Intercept, it's you kind of guess 3.5. Slope, you can compute, right? But it's not clear, by looking at it. So if I want to convert to a standard form, so then it's very easy. Just remember algebra. So now we are starting with the equation here. X plus 2y equals 7, right? So in the standard form means that on the left-hand side, I want to have y. I want to get rid of everything to the right-hand side, right? So now algebra is our friend. In this equation here, I want to hold on to 2y on the left-hand side. Whatever I don't want, I put it on the other side. So when I change the side, I change the sign, right? That's all I need to remember. X goes to the right-hand side, it becomes minus x. So 2y equals minus x plus 7. Okay, and the 7 is right there. You don't change anything, right? So now 2y equals minus x plus 7, but I don't want 2. I want only y. So I want to get rid of 2. So how do I do that? So I divide both sides by 2. So on the left-hand side, I get a y. Right-hand side, I divide by 2. So it's minus x over 2 plus 7 over 2. So that means that minus x over 2 means what? It's minus 1/2 times x plus 7 over 2. Now I have y equals, it's mx plus b. Plug it in. What are we plugging in? M equals minus 1/2. B equals 7/2 or 3.5, right? 3.5 or 3.5. So the slope of this line is minus 1/2. Intercept is 3.5 that you can see here. And it does make sense. Every time you need to check, I have minus 1/2. Does it make sense? Yes, the line is going down like a slide is going down. It's not going up. So I expect the slope to be a negative number, right? It makes sense to me, okay? So now here we've got a line and we've got a point. So the line is passing through the point 2, 2. So let's just say that it's passing through x1, y1, which is 2, 2, okay? And then rise over run 3 over 2, right? So again, remember, I've got one point here on the line. I'm going across, going up, and then I end up with another point on the line, exactly another point on the line. So the slope is 3 over 2, right? By looking at the line, I know that slope is 3 over 2, that is m, that's a slope. And then the intercept, I look at the picture here, and the intercept here, this is minus 1, okay? So b equals minus 1. So the equation to this line is y equals mx plus b, plug it in, right? So m is 3/2, b is minus 1, so y equals 3 over 2x minus 1. So if someone gives you a line, if they gives you a point, if they give you a slope, right? So then you can actually write down the equation here, right? By looking at the picture, you know the intercept, you know the slope, right? Then you can write it down. So in this case, I did not even use the point. I really use the slope here. I use the intercept, and then I'm able to write down the equation here, right? So somebody gives you a picture with the intercept and slope, you can actually write down the equation. Now, the same problem, sometimes they will not give you the picture, okay? So the problem here, it says that the line has a slope of 3 over 2, that's m. It passes through the point 2, 2, x1, y1, okay, passing through one point. What is the equation of the line? So in this case, they have not given me the picture. I don't know the intercept, okay? Then how do I find the equation? So whenever I know one point on the line, whenever I have the slope, I have to use point slope formula for the equation, okay? So this is not the standard form. Standard form is y equals mx plus b. There is another form for the equation, and that's called the point slope formula. Point slope formula says this. What that says is that the equation to the line is y minus y1 equals m times x minus x1, okay? So again, algebra is our best friend. Plug in. That's all we need to do. So everything that we know, we plug in. So y, write down y. We don't know what that is. y1, that y1 is exactly 2. So instead of y1, I'm plugging in 2. M, slope is 3 over 2. I'm plugging in 3 over 2. Then x, it's a variable. I put it, right? I put it just like that. x1, that is exactly 2 here. So I put in 2. So I plug in y1, plug in m, plug in x1 in the point slope formula. That's all I need to do. So then if you simplify y minus 2, here I've got a parenthesis here. So 3 over 2 times x, and then 3 over 2 times 2, right, minus. So that becomes 3. So you need to simplify. So now I have y minus 2 equal to this, but I want to write the equation in the standard form. So I want to have only y on the left hand side. Everything else I want to get rid of. How do I do that? I have to move to the right side. So when I change side, I need to change the sign. So I don't want minus 2. I'm going to change the side. So the minus 2 becomes plus 2 on the right hand side. Everything on the right hand side is exactly the same, but now minus 2 has become plus 2 on the other side. So now I just simplify. So y equals 3 over 2 times x minus 3 plus 2 is minus 1. So this is exactly same as what we did in the previous slide, right? Exact same thing. So if they don't give you a picture, if they give you 1 point and 1 slope, you will be able to use the point slope formula to get the standard form equation, okay? So now I've got, somebody gives me 2 points, 2, 3, 6, 4, and then they ask me, hey, how would you write the equation for this line, right? So I know how to join the line, right? So then I know what is the intercept of the line, right? If I look at that, that is 2.5, that's the intercept. So all I need to find is a slope, right? The slope is, so I've got x1, y1, that's the first point, 2, 3. And then x2, y2, 6, 4, that's the second point. And then the slope, if I take 2 points, and then if I want to find out the slope, the formula to find out the slope is y2 minus y1 divided by x2 minus x1, okay? Or the difference in the y values divided by difference in the x values. Delta y over delta x. That's what I mean, right? So again, it's the rise over run, the same thing, okay? So in this case, the difference between the two y coordinates, 4 minus 3 on the top. On the bottom, difference between the x coordinates, 6 minus 2, that's 4. So the slope is 1 over 4. So it's a very shallow line, shallow slope. You expect a small slope, it's only 1 over 4, 1/4, okay? Then by looking at the picture, you know that the intercept is 2.5. So now you know the slope m equals 1/4, intercept b equals 2.5. Then you can write down the equation in the standard form, y equals mx plus b. Just plug it in. Instead of m, you put 1/4. Instead of b, you put 2.5. So equation is y equals 1/4 x plus 2.5. That's the equation, okay? So, but sometimes they actually don't give you the picture. Okay, so let's say I don't have the picture, so I cannot get that intercept. Then what do I do? Okay, so then you can use the point slope form that I talked about in the previous slide. So the first thing you need to do, if they give you 2 points, you know how to find the slope if you are given the 2 points, right? So you just use the formula, rise over run formula to find the slope. So 1/4 is the slope. You already got that. And then you actually use the point slope formula here. So x1 x1 y1, so x1 y1, that is 2 comma 3. So the line passes through x1 y1 2 comma 3, right? So you can plug in y1 y minus y1. So y1 is actually 3. M equal to 1/4, the slope. We already computed that. X is a variable, I leave that alone. X1, that is 2, so I put that in. That's it, right? So then I just simplify y minus 3. I don't want 3, I just want y, because the standard form I want only y on the left hand side. So I need to get rid of minus 3. So I just move it to the other side. You change side, change sign, right? So when you move it to the other side, the minus 3 becomes plus 3. And then you simplify 1/4 x. 1/4 times 2 is minus 1/2. And then you simplify 1/4 x. 3 minus 1/2 is 2.5, right? So you get the exact same answer. Like here, you get the exact same answer. If they give you the picture, then you can directly get the intercept and then use this. But if they don't give you the picture, they just give you the 2 points, then you compute the slope, and then you use the point slope form, and then you can actually calculate the equation. Okay? Okay, so sometimes they will ask you to draw the line. So in this case, they've given the equation 2x plus y equals 2. The question is draw the line. Okay, when they say draw the line, you saw before, when I have 2 points, I can draw the line exactly, right? So the goal is to find 2 points on the line, okay? And you can find 2 points. I mean, there are so many points on the line, you can pick any 2 points, okay? So let's say how you pick 1 point. You know, the number 1 here, you can, in the equation, if x equal to 0, you can put x equal to 0. If x equal to 0, right, you plug it in, x equal to 0, then y equal to 2. So when x is 0, y is 2. So that means that the ordered pair 0 comma 2 is on the line. So you see on the picture here, 0 comma 2 is exactly on the line, okay? Similarly, you can pick any other x value. I could pick x equal to 1, x equal to 2, x equal to 10, x equal to 100. I could pick any x value, or I could pick any y value, right, for the second point. And the second point, you can pick anything you want. So in this example, I am picking y equals 0, okay? I put y equals 0. In this equation, I put y equals 0. What do I get? Plug it in, 2x equal to 2, x equal to 1. That means that 1 comma 0 lies on the line. So if you go look at the line, 1 comma 0 lies on the line. So now I have exactly 2 points, 0 comma 2, 1 comma 0, 2 ordered pairs. And then you just join the 2 points, and that's the line, okay? So if someone gives you an equation, ask you to draw the line, you just find 2 points, put x equal to 0, and then put either y equal to 0 or x equal to 1, x equal to 2, x equal to 3, any value you can put, and then you will get 2 points. And then once you get the 2 points, you just join the 2 points, and that'll give you the line, okay? So now, let's say that I've got 2 lines. I've got a green line, I've got a blue line, okay? I've got 2 lines. Each one has its own equation, right? So the blue line is 8x plus 2y is 48. That's that equation here. And then this green line is 4x minus 6y is minus 4. That's that equation there. And now the question is, what is the point of intersection? Okay, so if you want to solve these 2 equations, what that means is that what value of x and what value of y is going to satisfy both equations. So the ordered pair, that's going to lie both on the green line and on the blue line, okay? So when you have two lines, green line, blue line, when they intersect, they will intersect exactly at one point, right? Two lines if you draw, just two lines, you cross it like an X, right? Always there's going to be only exactly one point they will cross, okay? So in this case, if you look at the graph here, x equal to 5, y equal to 4, 5 comma 4, so that point lies on the green line, that point lies on the blue line also. So what does that mean? So that means that it has a lot of meanings. One meaning is the point of intersection of the two lines is 5 comma 4. Okay, so that's very obvious by looking at it. Okay. Another way of looking at it is I've got two equations, 8x plus 2y is 48, 4x minus 6y is minus 4. If I solve for x and y, then x equal to 5, y equal to 4. Okay, so it is a solution. So that point of intersection is the solution for these two equations because that point satisfies both equations, right? So there are two methods to solve these two equations. One method is a graphical method. You just find the point of intersection, so that satisfies both equations. That's very easy to do, right? It's very obvious here. But sometimes the point of intersection could be way outside the graph. Point of intersection could be x equal to 100, y equal to 200 or something like that. It could be way off the graph, okay? So then you will not be able to see the graph, okay? Or sometimes they will not even give you the graph. The question will just say that solve these two equations, right? So then we have done this in algebra before. You have to use the substitution method. That's what we did before. The same thing you have to do that here when you are not given the graphs or the point of intersection is not in the graph, it's way outside the graph, then it will be very difficult for you to see the point of intersection, in which case you have to use the substitution method. Substitution method means that, what does it really mean? I've got two equations in two unknowns. I don't know how to solve this, but I know how to solve an equation. We have solved the equation before. If I have only one variable, I know how to solve it. So that's what I need to do, substituting from one equation to another equation so that I make this equation in one variable. Okay, how do I do that? So for example, the second equation here, 4x minus 6y is minus 4. So that means that 4x equal to 6y minus 4. I'm taking the 6y to the other side. 4x equal to 6y minus 4. Okay. Now, if I substitute this in equation number 1, equation 1 says that 8x. So what do I mean by 8x? It is 2 times 4x, right? 2 times 4x. So instead of 4x, I'm substituting 6y minus 4 from the other equation. So that's what I'm doing. That's why it's called substitution method. And then plus 2y, I'm taking the same 2y. I'm not changing that. Only for this 4x, I'm substituting. 2y, I'm writing as it is. 48, I'm writing as it is. So what I have done with the substitution is that now I have an equation in exactly one variable y. Now I know how to solve this, right? So that's how the substitution method works. So now you simplify. 2 times 6y is 12y. 2 times minus 4 is minus 8. And then plus 2y is 48. Okay? So now like terms, 12y plus 2y, 14y, minus 8 equal to 48. So now I don't want minus 8. So I move it to the other side. When I change it to the other side, I change the sign. So 48, this minus 8 becomes plus 8, so it's 56. So 14y equal to 56. So I don't want 14, so I need to divide both sides by 14. So y equal to 56 divided by 14, that equal to 4. So y equal to 4. Okay, so I got that. Now I substitute this y in the second equation. So y equal to 4. So I substitute, so 4x, right? 4x equals, so 6y, 6 times 4, that is 24. Then minus 4, that's 20. So 4x equal to 20. I don't like 4, so I divide both sides by 4. So x equal to 5. So x equal to 5, y equal to 4. That's what exactly we got using this graphical method. Okay? So when the problem gives you two equations for you to solve without the picture, you have to use the substitution method. If the problem gives you two equations with the graphs, and if there is a point of intersection, it's very easy. You just look at the point of intersection and the x values, y values from that, and that'll be your answer. Okay? Okay, so sometimes the relationship between x and y may not be a line. Okay, so in this example, y equals f of x, that's a function or relationship we talked about before. In this case, y equals x squared minus 8x plus 12. Okay, so it is not a line, but it looks like a u. It's a different relationship. Okay, so whenever you have a function like this, then the question is, when x equal to 5, what is the value of y? Okay, so then you will answer, you just plug in, right? The plug in x equal to 5 in this equation. So instead of x, you put 5. Instead of x, you put 5. So 5 squared is 25, minus 8 times 5 is minus 40 plus 12. So when x equal to 5, y equal to minus 3. Okay, ordered pair, when x is 5, y is minus 3. Okay, so another question is, what is the minimum value of y? Okay, so when they give you this picture and from the graph, you see that what is the minimum value of y. So you see all the way to the bottom here, you see here y equal to minus 4. That's the minimum value. Okay, so you know, for any other function they give you, you know how to plug in, substitute, plug in and get the value of y if they give you value of x. And minimum value, just by looking at the graph, you will know what the minimum value is. Okay? Okay, so now these functions are actually used in real life, a lot of applications. So let's do two example applications using these functions. Okay? So the first problem here is the cost of bagels, C, is a function of n is the number of bagels. Okay, the function is given by this equation here. The cost C equal to 0.8 times n is the number of bagels, if n is less than 12. So if it's less than 12 bagels, then C is 0.8 n. Otherwise, C is 0.75 times n. Okay, so that means that if you buy 12 bagels or more, then the cost is going to be 0.75 times the number of bagels. So if you buy 12 bagels, how much would it cost is the question. Okay? So the first thing you need to look at, the number of bagels, n equal to 24. So you are buying 24 bagels for a party. Okay? So n equals 24. Now this n is more than 12, right? 24. So that means that you have to use the cost function C equal to 0.75 times n. Okay. So in this case, 0.75 times, you just plug in, instead of n, you plug in 24. So 0.75 times 24 is $18. So you would pay $18 when you buy 24 bagels. okay? So the second application here, there are 3 different jobs. For each job, the weekly pay, which is Y, is determined by X, which is the number of hours worked. X is the number of hours worked, Y is the pay, okay? For job 1, the equation or the function or the relationship Y equals 10 times X. The pay equals 10 times the number of hours you have worked. For job 2, Y equal to 70 plus 8X. For job 3, Y equal to 9X plus 50. The pay equal to 9 times the number of hours plus 50. Which job would you take if you work 40 hours? Okay. And they have given you the graph here. Okay. On the x-axis, you've got the number of hours, which is X, right? On the y-axis, the weekly pay, which is Y. Okay. And then this job 1 is the light blue line, job 1. The red color one is the job 2 equation. Job 3 is this one up at the top, okay? So if they give you the graph, and then it's very easy for you to make the decision, because if you work 40 hours, let's say you work 40 hours, so all you have to do is go up here. Job 2, if you go here, you are going to get $390, right? If you just go up for x equal to 40, you go up, then you go across, $390, okay? And then for job 1, for 40 hours, you just go up, you read across, and then that is, for that job 1, it's a little more, about $400. And then, so for 40 hours for the job 3, you just go up, you go across, that's about $410, okay? So then the biggest one, the most money is actually job 3, so you will go with job 3, right? So if they give you the graph based upon 40 hours or 42 hours, 44 hours, whatever the hours you work, you can read off the graph and see that which job you would take. And then if you look at this graph here, job 3, whether you work 30 hours or 36 hours or 44 hours or whatever number of hours you work, it seems like job 3 is going to pay you the most, so you will go with job 3, okay? But if they don't give you the picture, then what you have to do is this, when x equal to 40 hours, then for job 1, you need to find out how much you are going to get paid. Y equals 10 times x, just plug in 40. When x equal to 40, plug in x equal to 40, plug in x equal to 40, right? 40 times 10, that's 400. And then here, for job 2, 8 times 40, that's 320 plus 70, that's 390, right, for job 2. For job 3, plug in x equal to 40, 40 times 9, that's 360, 360 plus 50, right, 360 plus 50, that's 410. So for job 1, you will get $400, job 2, $390, job 3, $410. So you will pick job 3, okay? So this is the way in real life, if they give you functions, either by looking at the graph or by plugging in, you will make the decision, which, how much it's going to cost you or how much it's going to pay, those kind of things, okay? Okay, so we have finished all the important topics in algebra. So in this session, we are going to do some practice problems. You can follow along in the booklet that that is provided. So let's start with the first problem. The first one says that the product of a number and 5 increased by 7 is equal to 2 times the number decreased by 8. What is the number? Okay. So these kind of word problems, you need to read them little phrase at a time, and then you need to convert that to an expression. Okay. So let's read the first phrase. Product of a number and 5. Okay, number, I don't know what it is. When you don't know what it is, you just put X. So product of a number and 5, that means that 5X. okay? Then increased by 7, so that means that we are adding 7 to that, okay? Then is equal to, so put equals, 2 times the number, so 2 times the number means the x, okay, the number that we don't know, decreased by 8, so that is minus 8, okay? So read the problem and then you need to convert it to an equation like this. Once you write it like this, then it's easy to solve. So we know how to solve the equations. So we need to bring all the x on one side, all the numbers on the other side. So we need to bring, for example, 2x to the left-hand side. So when you change sides, you change signs. So 5x, I'm not changing side, it's exactly the same. 2x, when I bring it to the left-hand side, it becomes minus 2x, right? Then I have minus 8 on the right-hand side, I just keep it as it is. Then the 7, I'm going to take it to the other side. So when I switch sides, I switch signs, right? Plus 7 becomes minus 7. So now if you simplify this, 5x minus 2x, that's 3x. And minus 8 minus 7, that's minus 15, right? So now I want to find x. I don't want this 3, I want to get rid of 3. How do I do that? I divide both sides by 3. I need to be fair. If I divide the left hand side by 3, I need to divide the right hand side also by 3. So now that's cancelled. So x equals, then 15 minus 15 over 3, that's minus 5. So x equal to minus 5, that's the answer. So what is the number they're asking? The number is x equal to minus 5. Okay? So now let's move on to the second problem. Okay, so the second problem says, what is the equation to a line with a slope of minus 3 that passes through the point 3 comma 5? Okay? So you need to remember, we did two types of equations. One is the standard form, y equals mx plus b, where m is the slope, b is the intercept. So we did an equation to align another form when we know the slope and a point, right? So point on a slope, we wrote y minus y1 equals m times x minus x1, right? So these are the two different forms of equations to a line we did before. So in this case, so you always need to look at the problem. If they have given slope and intercept, then you need to use the standard form. If they give you a slope and a point, then you need to use this form, okay? So in this case, we have to use this form because point on a slope. So the equation is y minus y1 equals m times x minus x1, okay? So in this case, slope is minus 3, so all you have to do is just plug in. That's all you need to do. So m is the slope, we just plug in, m is minus 3, so plug in minus 3 there. And then x1, it's always like the ordered pair, the first one is x1. So the x1 is, in this case, 3. And then y1, 3 comma 5, so x1 is 3, y is 5, 3 comma 5, right? So x1 is 3, y1 is 5. So that's what we mean by point slope equation. x1, y1 is the point that the line is going through, okay? So now, so it's y minus 5 equals minus 3 and then x minus 3. So, generally, we write the equation in the standard form. So that means that I need to have y on the left-hand side. Everything else here, I need to get rid of those. So I don't like the minus 5 here. So how do I get rid of it? Take it to the other side. So when I take it to the other side, it changes the sign. Change the side, change the sign. So it becomes 5, right? Minus 5 becomes 5. Then I still have this. So now I can simplify this. 3 minus 3 times x is minus 3x. Minus 3 times minus 3 is plus 9. Right? So you just simplify that. So now 5 plus 9 is 14, right? And then minus 3x. So minus 3x, I write it the way it is. And 9 plus 5 is 14. So I can write y equals minus 3x plus 14. So this is in the standard form. Y equals mx plus b. So m is minus 3. That's a slope. And that's what we started with. So you want to make sure that when you write the equation in the standard form, the slope is minus 3. So that makes sense. And then the intercept is 14. Okay, so this is the equation to this line. So let's move on to the next problem. Problem number 3. The coordinates of point A is minus 3, 8, and point B is 5, 9. What is the slope of the line that passes through A and B? Okay, so we have 2 points. A is minus 3, 8, and B is 5, 9. Okay. So we covered this part before. So when we have, so this point is x1, y1. So we've got a point A, x1, y1, and then point B, x2, y2. And we want to find the slope of the line that's joining these 2 points. And the way we define the slope is always the rise over run, right? So the difference between the 2 y values, so that is the rise. And then the difference between the 2 x values, that's the run. Rise over run, right? So you just take y2 minus y1 divided by x2 minus x1. So in this case, y2 9 minus 8, that's 1. And then 5, okay, 5 minus, then you have minus 3. Okay, so let's just write on the top also. Say that's 9 minus 8, okay, we are just plugging. So always plug in, right? So in the formula, you just plug in y2, y1, x2, x1. But you need to be very, very careful when you plug in minus, you've got a minus, then x1 is actually minus 3. So you need to put a parenthesis, put minus 3. You have to remember the sign, okay? So now on the top, 9 minus 8 is 1. On the bottom, so it's a minus 3. I've got 2 minus, right? So that means that is 5 plus 3, so it's 1 over 8. So the slope of the line that's joining the points A and B, the slope is actually 1/8. Okay? So you need to be very careful when you are dealing with negative numbers. Make sure that you put the sign. Don't forget the sign. Okay? So let's move on to the next problem. Problem number 4. A phone company charges $25 per month plus $0.05. So that means that it's 5 cents, right? 5 cents for every minute after the first 1,000 minutes. The function for total monthly fee is f equals 25 plus 0.05 times n minus 1,000. If Tom used 1,200 minutes, how much would he pay? Okay. So the monthly fee f, so whenever you have a function, that means that you have a relationship between 2 things, right? That's an equation. So in this case, you've got f, that's the fee, monthly fee. And on the right hand side, it's 25 plus 0.05, and then n minus 1,000. N is the number of minutes. So function means that it is a relationship between the number of minutes and then the fee, okay? So the problems are very easy with the function problems. You just plug in the right number, right? So the question is, if Tom used 1,200 minutes, how much would he pay? So the number of minutes is 1,200. So all you have to do is just plug in here 1,200. So that's all you need to do in this problem, okay? Just plug in, okay? So now when you plug that in, what happens? So the fee equals 25, then 0.05, and then 1200 minus 1000, okay? So now it's 25 plus 0.05, 1200 minus 1000, you can do it in the calculator, so the difference is 200, okay? So then in the calculator, you can do 0.05 times 200, you can do that. When you do that, it's going to be 10. So 25 plus 10, again, you can use the calculator, you've got $35, okay? So what this is saying is that the first, the monthly fee is $25, so Tom is paying 25, no matter how long he talks. Then after 1,000 minutes, every minute he'll be paying 5 cents. So he talked 200 minutes over 1,000 minutes. So 200 times 5 cents, that's $10, right? So it has to make sense to you, right? So 25 is the fixed monthly fee. And then additional 200 minutes he talked, he's paying 5 cents a minute, so he paid $10. So together, overall, he paid $35. And the function fee is a function of the number of minutes, okay? So the function problems are very easy. All you have to do is just plug in the value of one quantity, and then the other quantity you will be able to get that. So now let's do problem number 5. It says that Tom's salary is $250 more than half of David's salary. Together, if they make $3,250, what is Tom's salary? Okay. So again, in these kind of word problems, you just need to start one little phrase at a time. So Tom's salary $250 more than half of David's salary. So I don't know what David's salary. So the David salary, let's say that it is X dollars. Okay. So I don't know that. Let me start with something that I don't know. David's salary X. So Tom's salary is 1/2 of David's salary. So that means that Tom's salary is 1/2 of David's salary, which is 1/2 of X, and then plus 250, right? So plus 250. So that's Tom's salary. So now together they are making $3,250. So this is David's salary, this is Tom's salary. Together means that if I add these two together, I'm going to get 3,250, right? So that's how you set it up. So I've got David's salary plus Tom's, together it's that, okay? So now X means that it's just 1X, right? So I can simplify, I can add these two together, 1X and half X, right? So that means that 1 and 1/2 X. It's a mixed number, right? 1 and 1/2. So and then plus 250 and equals 3,250. So we know how to solve this equation. So we keep all the letters, X on one side, numbers on the other side. So on the left-hand side, I have 1 and 1/2 X. And then I have to move this to the other side. When I change the side, I change the signs, right? So 3,250 minus 250, so that is $3,000. Okay? So now anytime I have a mixed number, I have to convert it to improper fraction, right? So 2 times 1 is 2, plus 1 is 3, so it's a 3 over 2x, right? Equals 3,000. Okay? So whenever I have improper fraction, so in this side I have 3,000, so I can just write that as 3,000 over 1, right? So it's 3,000. Anything divided by 1 is just that number. So once you have two the ratios of fractions on both sides, we know that cross multiplication is our best friend, right? You can immediately do that. So 1 times 3x is 3x, and 2 times 3,000 is 6,000. So then I just want to find x. So both sides you divide by 3, right? So it cancels. So x equals, so 6,000 divided by 3, when you use the calculator, it is 2,000. So now, the moment you calculate what x is, you cannot just stop and say, oh, okay, so the multiple choice, I have 2,000 and I mark it. You should not do that. You need to think, what did I do? So X equals 2,000. So X is what? It's actually David's salary, right? David's salary is exactly 2,000. But what is the question? The question is, what is Tom's salary? Okay? So you cannot say that the answer is 2,000. No. David's salary is 2,000. Okay? What is Tom's salary? Tom's salary is 1/2 of David's. So if David is getting $2,000, so we need to get 1/2 of 2,000, which is 1/2 of 2,000. If you do it in a calculator, it's 1,000. So 1,000 plus 250, right? So Tom's salary is 1,000 plus 250. So his salary is $1,250. Okay? So that's one way to do that. The other way is, David's salary is exactly $2,000, but David's and Tom's together is $3,250. So Tom's salary is going to be 3,250 minus 2,000, right? So then I get $1,250. So I can do it this way, or I can do it this way, okay? But the key is, as soon as you solve for X, you need to know that's David's. So now I need to get the Tom's. So how do I get the Tom's? So get the total salary minus the David, then you get the Tom's, okay? So you need to go all the way through, read the question, make sure that you are answering the question, okay? Okay, so that was problem number 5. So let's move on to problem number 6. Okay, problem 6 says that sum of 5 consecutive numbers is 160. What is the third number in the sequence? It says 5 consecutive numbers. So I don't know what those things are. So let's start as X. The first number is X. So what do we mean by consecutive numbers? So let's say, I have like a 10, 11, 12, 13, 14. These are all consecutive numbers, right? Consecutive means that just to take a number, add 1 to it. That's the next consecutive number. Add 1 to it, the next consecutive number. Add 1 to it, the next consecutive number, right? So you just keep adding 1 to that to get to the next consecutive number. So if I start with X, so the next consecutive number is X plus 1, right? So then I add 1 more to that for the next consecutive number, which is X plus 2. And then I add 1 to that to get the next consecutive number, so X plus 3. So then I add 1 to that to get the next consecutive number, so that's X plus 4. So I've got 5 consecutive numbers. So now the problem says that the sum of the 5 consecutive numbers is 160. So that means that X plus X plus 1 plus X plus 2 plus X plus 3 plus X plus 4, add all of them and I do get 160. So that's what the problem says, okay? So now we know how to simplify this, because we can, all the like terms like this, all the x's, 1, 2, 3, 4, 5 x's I have. So 5x, if I add all the 5 x's, I have 5x. Then I've got number 1, 2, 3, 4. So if I add all the numbers, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, right? So I have to add all the letters and all the numbers. That's how I simplify the expression, right? And then on the right hand side, I have 160. So now I've got an equation. Now I know how to solve it, right? So I want to find X. So I don't want the 10, so I need to get rid of this 10. I need to take it to the other side. So when I change the side, I change the signs, right? So 5x, I keep it on the left hand side. Then 160 on the right hand side the same. The 10 goes to the other side, so it's minus 10. So that is 150, right? So 5x is 150. What is x? So now I don't want 5, I just want x. So I need to divide by 5. Then to be fair, I need to do the exact same thing to the other side, right? So now this gets canceled, so I have x. X equals 150 over 5. So that is 30. So x equals 30. okay? So as soon as you solve, then as I said, you need to go back. So what did I do? So I got x equals 30, right? So that's the first number. The next number, 30 plus 1, that's 31. Next number is 32. Next number, 33. Next number, 34. So those are 5 consecutive numbers, right? So now when you add 30 plus 31 plus 32 plus 33 plus 34, you should get this 160. Okay, you can verify that, right? So now you read the question, what is the third number in the sequence? So the third number in the sequence is 32. Okay? So you need to first set it up, and then you solve the equation, and you get x value. Then you go back to the problem, see exactly what you have done before you answer the question. Okay? So once you get used to these kind of problems, then it's going to be very, very easy for you. Okay, so let's move on to the next one, problem number 7. So an equation to a line is 3y plus 2x equals 9, okay? What is the slope? What is the intercept? Okay, so anytime they ask the question, what is the slope or the intercept, okay, and they've given you an equation, so you need to remember the standard form of the equation y equals mx plus b, where m is the slope and b is the intercept, right? So if I can write the equation in the standard form, then I know what the slope is, then I know what the intercept is. So my goal is what? Rewrite this equation in the standard form. So the standard form means I need to have y on the left hand side. All I need to have is just y, okay? So here I have 3y plus 2x is 9. So I want to have only y on the left hand side, right? So the first step is I need to get rid of what I don't want, okay? So this 2x, I don't want the 2x, okay? So I need to take it to the other side. So the moment I do that, on the left hand side, 3y, that's still there. And then the 2x, when I take it to change side, I change the signs, right? 2x becomes minus 2x. And then the 9, so I have 9 means a plus 9, so it's plus 9. So you should not say that's minus 2x times 9, it's a plus 9, right? I'm taking plus 2x and minus 2x, so it's adding. Minus 2x is added to plus 9, what I already have. So you need to know that when you take it to the other side, it's a minus 2x plus 9, okay? So now, I don't want this 3y, I just want y, right? I want to get rid of this 3. How do I get rid of this 3? I divide by 3 on the right hand side. Every one of this I have to divide by 3, right? So I need to be fair. The divide by 3, every term on the right hand side, I need to divide by 3, right? Okay. Now, this is gone. So on the left hand side, I got y. That is good. On the right hand side, I have minus 2/3 x. Then 9 divided by 3 is actually 3. So now, I have the equation in this form. Y equals mx plus b. Okay? You always write it down. So and then all you have to do is just plug in thing, right? So you just look at this here. B is 3 like this. Look at here. M equals minus 2/3. So y match. X match. So this means that m equals minus 2/3. So that means that the slope is exactly minus 2 over 3. That's a slope, negative slope, okay? And then b equals 3. So that means that the intercept is exactly 3. So that's a question they're asking. What is the slope? What is the intercept? So you will write slope is minus 2/3 and intercept is 3. So it's always plug in. That's all you need to do. Okay? So now let's move on to the next problem. Problem number 8. An equation to a line is 7y plus 5x equals 12. Thus, the point 1, 1 lie on this line. Okay, so you want to check whether this point lies on this line. So again, if you want to verify whether a point lies on the line, all you have to do is just plug in, okay? So this is ordered pair, so it's always x first and then y second, right? So all I have to do is plug in the value of x and y in this equation to see whether that is true, okay? So all I have to do is 7, and then in place of y, I plug in, y is 1, I plug in 1, and then 5, and then x is 1, so instead of x, I plug in 1. Then the question is it equal to 12, right? So 7 times 1 is 7, 5 times 1 is 5, equal to 12, yes. The left-hand side equal to the right-hand side, that is true. So the 0.11 lies on this line, yes, that is true. Okay, so this is how you do that. Just plug in the value of x and y, and then see whether the equation is true. If it is true, yes, the point lies on the line, okay? So now let's do problem number 9. Problem 9 says that an equation to a line is, same thing, 7y plus 5x is 12. Does the point 5, 6 lie on the line? Okay, so now they're asking 5, 6 on the line. So if you actually have the picture, then you will be able to see whether the point lies on the line or not, right? That's another way to do that. If the picture is given to you, then it's easy. But if they do not give you the picture, they do not give you the graph, then you need to see whether this point lies on the line by by plugging in, right? So it's x is 5, y is 6. Okay. So now I want to know whether this point lies on this line. So I plug in. So now 7, and then instead of y, I need to plug in y is 6. And then plus 5. Instead of x here, I need to plug in x equals to 5. I need to plug in 5. And the question is it equal to 12? Okay. So 7 times 6 is 42. 5 times 5 is 25. Okay. Is it equal to 12? So if we add it, so this is 67. So 67 is not equal to 12. No, this is not equal to 12. So that means that 5, 6, the point 5, 6 does not lie on this line. Okay. So either looking at the graph, you will be able to see visually whether the point lies on the line, or you just need to plug in and see whether the equation is true. If it is true, then it lies on the line like the previous problem. If it is not true, in this case it's not true, so that means that this point does not lie on this line. Okay? Now let's move on to the next problem. Okay. An equation to a line is 5x plus 9y equals 45. Find 2 points that lie on this line. Okay. So a lot of times they will give you the equation, ask you to actually draw a line on the graph paper. Okay. So in order to do that, you know that when you have 2 points on the line, you can just join the 2 points and then you will get the line, right? So the goal is to find 2 points on this line. How do you do that? So there are so many points on the line. So you can pick any, for example, you can pick any x value. So I'm going to pick x equal to 0. Let's just pick that, just some number, x equal to 0. And then I just need to plug in here. Right, so x equal to 0, I plug in here. So if I plug in 5, 0, so that's 0, then 9y equals 45. So if I just plug that number, so that means that 5 times 0 is 0, so I don't need to worry about it, right? That's gone. So 9y is 45, okay? So now I don't like this 9, I need to get rid of it. So just both sides I divide by 9. So now it's y, and then 45 over 9, do it in the calculator, y equals 5. So what this tells me is that when x is 0, and then y equals 5, So the ordered pair 0, 5 lies on this line. That's what that tells me. Okay, so I got 1 point on the line. Now I need to get the second point on the line. For that I can use anything. I can put x equal to 2, x equal to 3, x equal to 5. I can use anything, right? So any value. So what I'm going to do is I'm going to put y equal to 0, okay? So when I put y equal to 0, so then I just plug in, right? So 5x in that equation. Then 9 times y is 0, and that's 45, okay? So I plug in y equals 0. So now that's gone, right? So 9 times 0 is 0. I don't need to worry about it. So it's 5x is 45. So now I need to find x. I don't like 5. I need to get rid of 5. I divide both sides by 5. To be fair, I need to do the exact same thing on both sides. So now cancel that. So x equals 45 divided by 5. That's 9. You can use it in the calculator. So what this tells me that when x equal to 9, so I can put 9 first, then y equal to 0. Okay? So remember, it's not 0, 9. You need to remember, always ordered pair, x is first and then the y. So this is my point number 1, this is my point number 2. So I got 2 points that lie on this line, okay? So by using this method, putting any value, x is 0, x is 1, x is 2, or y is 0, you can put anything and then get 2 points. The moment you get this, that's all in this problem they're asking for, so then these are the 2 points on the line. Then if they ask you to actually draw the line, so then you've got 2 points here, and then you just join the 2 points, and then you'll get the line, okay? So that's pretty straightforward. So all you need to remember is just plug in. That's all you need to do. And the last problem is problem number 11, okay? So find the point of intersection of these two lines, y equals 2x plus 9, and 4y equals minus 4x plus 12. Okay? So as we reviewed before, these kind of problems you can do, 2 ways. You can actually draw the 2 lines in the graph paper and find out where the point of intersection is. So it'll be like an X, and then you find the point of intersection, right? You can do that. So if you feel comfortable, so then all you have to do is, just like the previous problem, find 2 points on this line, x is 0, y is 0, whatever you put in, get 2 points, get the line. Similarly, you get the 2 points on this line and get the line, okay? And then see where the 2 meet, and then graphically you can find a point of intersection. That's one way to do that, okay? So sometimes it's difficult to do that because the numbers could be very big. It'll be outside the graph paper. So then another method, substitution method, you can use to solve these 2 equations. So I'm going to use the substitution method, okay? So I'm going to show you how to do that with the substitution method. So in this case, so this says that the first equation, y equal to something, okay? And then the second equation, 4y equal to something. So all I have to do is, I'm just plugging, substituting here, 4, and then this y value. So the y, from the first equation, I know that y is 2x plus 9. So all I'm doing here is substituting. That's why it's called substitution method. Instead of y, I'm substituting that value from the first equation, okay? Then the right hand side, I'm not doing anything, so it is there, exactly the way it is, 4x plus 12, okay? So now once I substitute, the next step I need to do is just simplify, okay? So 4 times 2x, that's 8x. 4 times 9, that's 36. And then minus 4x, and then plus 12, okay? So then we know how to solve this equation. So we need to get all the letters on one side, all the numbers on the other side, right? So 8x is here, so I'm going to hold down to that. And I'm going to bring this 4x to the left-hand side because all the letters, I want to group them together. So then when I change side, the sign changes. So minus 4x becomes plus 4x, okay? On the right-hand side, the 12 is exactly the same. I'm not doing anything with that. But the 36, I need to bring it to the other side, right? So right hand side, I want to get the number 36. And then when I change side, it changes sign. So plus 36 becomes minus 36. So now I simplify again, 8x plus 4x, 8 plus 4 is 12, 12x, right, equals 12 minus 36. Can do it in the calculator, it's minus 24. So then I don't want this 12. So to get rid of that, I divide both sides by 12, right? So this is gone. So x equals, so this is minus 2. So I've got x equals minus 2. I solve for x. So now I want to find what is the y value. Okay, so I can go back again in this equation, plug in the value of x, then I can get the value of y. So take this equation, so this is y, and then I know that x equal to minus 2, so 2 times, put x equals minus 2, and then plus 9. I just plug in the value of x, which is minus 2. So 2 times minus 2 is minus 4, and then plus 9, and you can do it in the calculator, so that's actually 5. So what this is telling me is that when x equal to minus 2, y equal to 5, so that is the ordered pair, and that is a solution. So that means that when x is minus 2, y is 5, that satisfies these two equations. Another way of saying that, when you draw these two lines, when they crisscross, the point of intersection is minus 2 comma 5. So this point lies on the first line, this point lies on the second line also. So when one point lies on both lines, what does that mean? So it is at the intersection, right? So that is the solution for this problem. Okay, so with this, we are pretty much done with algebra.